And here we are. So maybe you've seen, or if you've been notified, or you've seen just before that I've created a stream where I wanted to fix the cable. This is, now let me improve. So the dashboard you see here, on this dashboard, you see the measurements from my multimeter and from my power supply. The measurements from my multimeter won't display anymore, and it turns out I wanted to debug why. It wasn't a software issue, because, well, the software didn't change too much. The problem was in hardware. It couldn't get any data over serial, and I wanted to check why this is, and I wanted to debug it with you live. But as I've started preparing the parts so I can show them, I've seen that it was just a broken cable. So I soldered a broken cable, and now it works. And the setup, well, here you can see the multimeter. Here on the back is just a photodiode. This is just a photodiode, photo receiver. And this is then connected to a USB to serial converter. Normally it is connected to DE9 connector, so this RS232, and it should give RS232 output. So you would then need an RS232 to UART converter, but you can actually cut the cable and make I can show it to you actually, and make a USB to serial and use a USB to serial adapter. And this is this the right input? No, wrong input. Right input. This is the whole USB cable mess, and this device, whoop, camera is not stable. I should strap it on a bit better. Okay, that's not stable anymore. The arm camera is sliding. Come on, arm camera. Okay. So this is my USB setup. Here there is a connection to the, so here you see 1 and 2. These are the two power supplies. This is the power supply which is connected to the dashboard in which you're seeing. This doesn't have Ethernet interface, USB interface, so it's just my secondary power supply. It is a bit older, and it was my first before I got this one. This power supply is connected here. The multimeter is connected here, and this is the hack. This is actually just a USB to UART converter, and I've connected the cable from the output of the cable, DE9 cable, and then there is just a transistor which you see in the glue here. What you see in the glue here is just a transistor to invert the level, because RS232 levels are idle low and then the bit goes high. UART is the inverse. You are idle high, and then the 1 bit is when it is, or the start transitioning when it goes low. This is why there's this transistor, and this transistor is only there to invert the level. And yeah, the rest is just, this is a mix, so I can change the HDMI output. Here we have 2 HDMI grabbing cards, and then we have plenty of cables going to the bench. If I press on here, you will see that we are back to the arm camera. So this is what you've missed somehow. This is what I've done off stream now. And I fixed it because I just had it glue and I resoldered it. There was no glue on it. So this is done, and because it is very quick and there was nothing to debug, no oscilloscope, no multimeter to make, I didn't care making a stream out of it. But what I want to make a stream out of is now, as the title says, convert tablets to power banks, because in the last project we have yesterday and before we converted this UHF receiver into battery operated. Here I use, I have to write power. Here I have the power to enable the internal battery. There's an internal battery. This is to charge the internal battery, but I still want to have the possibility to have external power supply, to have some kind of external power bank, but not a USB power bank. So where I just have USB output, I want to have a bit more. For example, I want to be able to give this in and to input 13 volts or things like that. And one easy way to have plenty of power is, this is the first thing we will do. Just use a lead acid battery, and then we'll probably connect here. So we will just make a connector for the lead acid battery. This will be the first task. Afterwards, I will have here. What I buy sometimes on eBay is a convolute of broken things. These tablets are broken. You see, I've tested them. LCD okay, it boots, but the touch is it's KO, so it means the touch is broken, and you can pretty much see from there. Also, touch is broken. This actually works. I got it working, but I will never use this tablet anymore. I use them as donor board to train if I want to desolder BGAs and so on. But the advantage of them is that they have huge batteries inside. So we will reuse this as just a battery with a fancy charger. But this is for afterwards. Let's start with the battery. This should be rather quick. I want to add this small device. This is just a voltmeter for the battery, and this way I can check the power which is there. So the battery is not completely full, but yeah, good enough for now. What's the voltage? It just measures the voltage and it is calibrated so that at a certain voltage it tells that there's no energy anymore. Oh, I have too many cables here. Up. So normally, so this is a 12 volt nominal battery. You shouldn't drain more than, shouldn't go under 10 volts, I think. And when it is charged, it is at 14 volts. And this is at, 13 volts. So we could actually charge it before we go. And because I don't want this to be connected all the time, because the LEDs will drain some battery, we will add a small switch on the side, or a button actually. Let's add a button. Does the stream still work? One stream works, the other still doesn't work. The camera, this overhead camera doesn't work anymore. Let me just restart the OBS for the head camera. Oh, I see there are plenty of issues. USB issues. It is restarting USB all the time. Why is it not stable? Streaming. The stream should work again, and the camera should be there. USB is really a pain. What I also changed is my USB hub. I previously had this USB hub, which is a true 7-port USB hub, because generally when you buy 7-port USB hub, there are 2 hubs inside, and it is not one port, but it is going one level deeper. I hate this when they do it this way, and this is the one which I actually have here. I hate this because you lose 1 drop, and I think you can only go 4 drops deep, 4 hubs deep, and yeah, you have 1 drop less just because they want to use cheap USB hubs and they put just 2 times 4-port USB hubs. This one didn't do it. And actually the new one I have is also a D-Link. It's the same model. It's just that the version changed, and with the version change they just have another hardware revision. So this is A4. Now you don't get A4 anymore, you get just newer ones, and they have 2 USB hubs, which is, I hate it, but there's nothing else there's not a lot you can do. So now it seems halfway stable. I hope the USB is stable for now. I'll check the stream regularly to see if it works. We see that USB, it works. Okay, so I have plenty of, so yeah, let's do that first. Let's switch on the soldering iron. This I don't need. And let's have a button. Yeah. use a button, and which one will we use? The blue button, so it's really visible. How will we mount it? It would be nice if I could press on the side. So this button is not good because the leads are down, so it's hard to make it work this way. What about the usual 6mm buttons, run of the mill? This would be nicer because I can somehow glue the button on the side. Let me heat up the glue gun. Yeah, I think I'll have it this way, because probably this way. So the plus is the plus is on this side. I'll also want to solder it on the battery, and for that to place it on the battery, I will break these tabs so it can be flush on the battery. Up, up, up. Now it can be flush on it. Let me start. Is this cable long enough? Yes. We will use this. Now I have two hot glue pistols, guns. This is the black one, and we will use black because the battery is black and the readout is black, so we will use black. This is on. This for now we don't need. We will need it just afterwards to test if it works. For now we want to connect this battery. So we will have minus here. Do I want to solder the cable directly, or do you want to not solder it? I think I'll solder it this way. I don't lose it. I don't have to reconnect and disconnect it all the time. I'm not sure how easy it is to solder on this thing. We'll try. For now, let's take care of the button. Oh, it fits nicely. And yes, how this button, I often forget, but I think these two pins are connected and these two pins are switched. Let's try it out. Multimeter, continuity mode, and if I'm correct, these two pins alongside are connected. Yes, they are. Yep, that's how it is. So we can have this slide in here. Come on. Yeah, we can fit it in here. Put some glue and then solder the minus terminal here on one side and then on the other side. And this circuit is this is probably the voltage regulator. This is the driver for comparing, for driving this LCD, and probably also the microcontroller. Or maybe it's just a 4-stage thing. Yeah, there are a lot of resistors. I think the resistors are to set the levels. So this is probably just a graph chip which drives the LED segments on this display, on this LED display. And yeah, the resistors are probably the thresholds. So we will solder the cable first. So this cable comes here. Let's get up the wire stripper. Ooh, there are plenty of cables on the way here. Solder, lead-based solder. Oh, the camera. This USB hub died again, or did This thing die. The overhead camera is again dead. Let me restart. Yes, and I see that it got disconnected. No such device. Why did it disconnect? It didn't tell why it disconnected. Let me start the stream again. And here we have the stream again. Let's see how long this holds. Ah, somebody is ringing. Back. Does the head camera still work? It doesn't, does it? Else we should see the cats, but the cat is not working. So the camera doesn't work. Let's try again. I hate this streaming. You are broken. You are broken. And the stream should work again. Sorry for the delay, and I hope so. This is a real get hack. I don't know why on this USB hub right here, which is there, it every time I access the HDMI grabber, it just stops. It's reset the HDMI grabber, and this way I can't go forward. I have no idea why. I don't want to debug it now. I'm already a bit annoyed by this hardware, but it's hard to have good hardware. And what do I expect? I'm using cheap HDMI capture cards. They are really cheap, but you get what you pay for. It's my own fault. So let's continue. This camera does not work. Okay, the second HDMI grabber is dead because it takes 30 seconds of delay. Start. No, I am streaming. Quality excellence. It says excellent connection. Okay, it works. So I have no idea what's happening. If this fits to a USB hub, if it's the dongle. I've connected the devices directly to my laptop, not going through this USB hub. For now, it seems to work okay. I have to debug this USB setup yet another time. But not today. Yeah, having a strong setup is not easy. I should use HDMI capture cards. HDMI capture cards, that's for sure, but on PCI and not on USB because it's a lot more stable. But then I need computer. tower computer thingy, which I don't have. With a central unit, I'm just using my laptop. But and at least I have no followers which are on the live chat, so I don't know if anyone drops, because no one knows about this stream. So this is the first part. Zoom a tiny bit so you can see a tiny bit better what I'm doing. So this is the first cable, and where is the second part of the cable? We've cut it. And where did we cut it? With all the mess I made with the USB, did I put the cable away? Here. Here's the cable, and now something fell. Okay, this is nothing important. This was just my particle sensor, and yeah, camera still works. Yeah, I have to find a solution for this mess, USB mess. Up. Let's put a tiny bit here. Actually, what is plus? This is plus. Okay, this is minus. It's on the plus side. Okay, now we have the switch to press whenever we need to do the measurements. We can have this cable come out here, this cable come out here. Can solder. Can we solder on this thing? Let's try it out. And this is why a very powerful, I'm not sure if I will be able to solder on it because of the huge thermal mass in even my super soldering iron has issues soldering everything. But it seems to be solderable. It's not looking super nice, but it is holding. Let's add a bit of solder for it to hold better. It is holding, so I'm happy with it. And same, do I want to shorten this cable so it really fits exactly what I need? No, because I still want, although, yeah, I'll shorten the cable. I won't use it anywhere else, so let's shorten the lead exactly where we want it. Okay, I need to desolderate this. Maybe there I need to use my other soldering iron. I can set the temperature really high. So this will come here, so we'll cut it here. This will come here, so I'll cut it here. Let's prepare the cables. 1 and 2. Let's tin the wires. Maybe if I don't think that flux will help on these pads. This way we can still try though. Let's see if it helps a tiny bit. Tiny bit of flux. this connector is so large. One. I'm sure it doesn't hold too strongly on it, but the glue will hold everything in place. Oh, wait, you shouldn't. What the hell? You shouldn't show anything. You should only show when I press on it. Ah, I did it the wrong way. We've tested it and I still did it the wrong way. It should go in this way. Okay. Now it's the correct way. And this, yeah, it doesn't hold on it. What I could do is have a ring terminal and have it all the time on here. This allows me to remove it if I don't want to. Let's have that. Let's have a ring terminal. I need also this part. This is the fan, so I can cool. Yeah, this is the fan, so I can cool the parts off. Hup, hup, hup. Fan. Let's have ring terminals. Ring terminals. This is my box with the ring terminals, and we can actually crimp it. Crimp. I have a huge stack of crimps, and not a lot of them are really useful. So, crimping terminals. Up. We want red for plus, and we want it to fit in here. Nope. Yes. That works. Let's crimp it first. Up on the lowest setting. No, not the lowest. My microphone is next to my. Let's crimp it to the next. I don't know if these colors mean really something. If there's a standard size versus color thing. This holds well, and black. This is huge, but does it fit? Yes, it fits. Because this is larger, I think I will need. I can crimp this a bit more. Crimp. I mean, have longer lead. And then let's try to crimp it with the largest. Whew, this will be hard. I already feel I don't have enough force. I need both hands to crimp it. But it holds. That's a good news. Yeah, the cable tech test, the cable holds, so this is good enough. So let's solder. Let's solder. Let's connect one side. connect the other side. If I press on the button, we should see the voltage. Yes. So this works. It means that now we can glue everything. Here, this. So this doesn't fall off. Let's connect the fan. This I don't need anymore. Switch on the power to the fan and let it cool our parts. We have to wait until it is matte. This way we know it is solid enough. It's not a very good glue which I added. Let's add some on the side. Okay, that's better. So, is it? No, it's not matte yet. It's still very shiny. And as long as it's shiny, it means that the glue is still warm. Although it's not anymore. It's holding correctly. So now let's glue this in place. Just add glue all around. Let's test if it works. Yes, it still works. Now we glue all around. No, okay. Ooh, it looks very bubbly. Doesn't look very nice, but I'll clean it up afterwards. Once it is solid, as long as it is liquid, it's not easy to clean. Oh, it goes solid very fast. So let's try to clean it up a bit. Up. I'll use cutter. Up. We can put it this way for it to cool. But it seems already cold. So this glue is a bit faster to cool down. Okay. This side looks nice. This side is okay. And this side looks almost finished. This is the small spillage we had. Up, remove the spillage. Up, and it is mounted on it. So now I always have a battery indicator if I need to. And I need to charge it. Come on. That's part one. Does it still work? Yes, it still works. They should have included this on the battery. Like you will find off some power banks, you find a level meter. At least this way. I have a level meter and it is strong. I can move the battery with it. Probably not lift it, but at least move the battery. It holds good enough. So now we need to have some spades which come from here and go to the power supply, and for that I have plenty of these super large cables. Let's find a cable which already has, oh, this looks nice. It's not very long, but it's long enough. 2.5 millimeter, no, 2.5 millimeter inside barrel jack. Let's try to find one which is a tiny bit longer. I have none, but I have one with, no, that's something else. There's nothing on there. This is short. This is longer. This is longer. Since the battery is huge, I want to be able to place it somewhere else. This is the longest I have. So let's use this one. Up, and this time I don't want, ooh, this looks, yeah, that looks okay. It's been soldered somewhere. I don't want to have rings because I want to be, don't want to remove completely the screw to remove this. We will have spades, or I don't know, U terminals. I don't know how they're called. I don't have them here, but I should have some spades here somewhere. This is my box with spade terminals, and this U shape, that's what I want. This way I can clamp it in here, have the battery voltage come out. 1, 2. So because the cable is already done, I use this, one of my very first QVoodoo videos on my website. I presented a ceiling light system, which I had in my previous apartment. And this ceiling light system used these cables, thick gauge, to bring the 12 volts to the light bounce. These don't look nice. Let's cut them and let's prepare them again. Yep. Better. This is better to crimp. And this crimping tool just removes the insulation. When you want something precise, I prefer using this because there I can choose the size of the cable really. If I just want for huge cables, for example, or if for fast things, this works most of the time actually. But I'm more used to this one, more compact and more precise for dummy cables. So minus is crimped, and you see that it crimps all the leads, all the strands inside correctly, so it makes huge contacts and lowers the resistance. Let's do the same here. Okay, let's try it out. This is plus. This is minus. And we will measure if we have 12 volt outputs. The knife goes on the side. I'm not sure, I don't need the glue gun. Let's switch off the power to the glue gun. And inside now I should have 12 volts. Multimeter, yeah, you still see the measurements. And I have 12.5 volts. So this works. Now let's test if it works with this. Let's put this on the side for now. I don't need this anymore. Up, up. So here, that's the input. It doesn't switch on. That's good. I need the microphones. Let's try to switch it on first. Okay. 12 volts is probably not enough. Does it work with does it work with 13 volts? That's weird that it doesn't work with 12 volts. Power supply. Here my leads to my power supply. Up. Maybe it was the other reason could be, yeah, that might be the reason. This might be a 2.5 millimeter hole. This might be a 2.1 millimeter hole, so it doesn't make the contact inside. Let's try. Let's set the voltage to 12 volts and see if it works with 12 volt input. It should, since the calculation last time. Yeah, we see it is already drawing, and then it can switch on. So there should be no issue with that. Let's test if we still have 12 volts here. Oh, we don't. Did something get loose? Did I break the wire here? Yes, I did. I broke the tab. I broke the tab right there. Let's try to solder it back on. Could make another connector, but this looks good enough. Up. And this is how I debug all the time, the error, the mistakes, and I'm good at debugging. And whoa, okay, no, I need something else. I need another connector. I don't have the lead to go there. Again, let's use another connector. Up, this goes away in the trash, And then connectors, I should have plenty of them. Here my box with these connectors, and I don't have... Oh, that's a shame. I don't have the connectors anymore where I can just screw on. Screw on where I can put it in. Maybe I have them in here in the box. I might have some additional ones. Oh, I have the female parts. I don't have the male parts. So using this long cable turned out not to be useful. Well, we can use something like this. Have the leads there. So the leads here are not very thick, but they're very high resistance, but they will be short. And because they are short, it doesn't matter too much. I don't have any leads, and you know I don't. Oh, I have to pay attention that I don't short these two cables, because this battery can deliver 100 amps. I'm lucky that it didn't short yet. Oh, is this good enough for so many amps? This is really thin. I don't like how thin it is. I could use something like this, but it's, yeah, probably I'll use something like this. Yes, I'll use something like this. I have enough of them. Yeah, I have enough of them. It's kind of a waste to use something so beautiful and with a screw, but I have enough of them, and for such high currents I prefer having that. So let's cut this again up, and let's have the leads. prepared. Not long, so I don't want to short them between both of them. Plus and minus is inverted. It's written on top, which is plus and minus. Actually, plus means center. That should be a bit clear. Better done, but very often plus is center. I only see reverse polarity on very specialized equipment like telecommunication equipment and things like that. And very old equipment. One of both. There are some reason why you want to have the center negative and the outside positive. It's because of electrolysis. If you are on the outdoor, you don't want it to rust or eat away your material, your housing, and to make holes depending on the metal you have. So to prevent electrolysis, because you have the whole chassis at a certain voltage compared to the rest, then you put the positive on the outside. Okay, that should work now. I don't want to test. I'm confident enough that this will work. This, I won't use it anymore. No. Up. Up, up. That's trash. That's trash. That goes here. That goes here. We have plenty of remainings. Up. This, what is this? Oh, stray cable. Up. Okay, this goes there. This goes there. Let's try it again. And I hope that this time it works. Up. Yes, it works perfectly. I think with my... do I want to test it? Yes, I want to test to be sure that the audio also works. So let's get the microphone and the audio output. Microphone, audio output, and I need some batteries for the microphone. Yep. Microphone, batteries inside. Audio output. These leads, I don't need them anymore for now. I'll need them for the next project, the main project actually, what this video is for. Let's switch on this device.
The Bluetooth device is ready to pair. The Bluetooth device is ready to pair. The Bluetooth device is aux input mode.
Aux mode, okay. Now did I put the battery the wrong side around? Yes, I did. Now it works. Yeah, the UHF receiver receives this thing, and now if I talk and if I switch, does it work? Hello? Audio.
Aux input mode.
There is no audio output. Yes, because I didn't connect it. And if I connect it, it works. Yep. I hear sound from here, so this works correctly. Okay, so this hack works, and this is ready. And whoop. And this is also what I'll bring tomorrow for the wedding, using this cable. I have to charge the battery though. We could do even something better to switch on and off. What we can have is something like this, which is just a switch. So we plug it this way, this in here. This way we can switch on and off without unplugging the battery. I'll bring one of them also. This is the first thing. So project 1 accomplished. Let's put this on the side. And let's come to the main topic. This goes to the side. This too. This too. And the main topic. Let's start with this tablet. Up, Acer, icon tab. That's the tablet. It completely works, even the screen works, and that's me, but I don't really care. It has even an output which I've tested, and it can output 2 amps. So we can already use this device as a power bank, but I want to tap directly not on the 5-volt output, but on the battery output and have a low voltage converter. So, let's try to open this device. Oh, this will be really a pain. Is it possible to open this device? Let's try with another one, which is probably easier to open. This one, Samsung something. It has 3G modem and so on. USB charger, micro USB, and it still works. It works even. Yeah, I've even flashed it, but it's not supported anymore. That's the issue with this tablets. After 2 or 3 years, you can't use them anymore because you have no updates. You can't root them, you can flash them, you cannot nothing with them. So it's a paperweight, and we will use it as power bank. Sure, it has a huge processor. It has an LED. It has a TFT. It has plenty of powers, but in the end, this tablet will be the fancy version of this device. So this device is a battery charger with battery protection, and we have 2 LEDs for indicating if it's charging and if it's full. Well, 2 LEDs are just, this is not IoT enough anymore. 2 LEDs is too simple. We want something better. We want to have a full Android stack with a huge TFT display to show if the battery is charging and if the battery is charged. That's the 2020 way to do things. And it's internet capable. So we have an internet capable battery charger. Power bank. Yeah, battery power bank. Isn't that amazing? Simply because devices are not supported anymore. So let's have a look inside. This is the easiest to open. The other ones will probably be a lot harder. Up, that's the inside. And here we have a huge battery. This is probably the LCD driver. I don't know why this magnesium metal bracket is. Oh, there's even... The cat makes too much noise. Okay. This is the... Yeah, we have here the main CPU. This is the main CPU, very probably. This is speaker 1, speaker 2. Here we have the USB interface. This is the LCD interface because there are plenty of tiny wires. I don't know what this is. This is probably the charging module. No, it's not. The charging comes in here. This is taking care of the charging. This is the battery. What I want to is verify if I can tap directly here and if it has battery protection on the battery itself. So this will be used to charge the battery, and this is the output of the battery. First, is it so 6,800 milliampere hours, but is it for 3 7 volts, or is it a 1S or a 2S battery? Are they in parallel or are they in series? Let's measure the outputs this way around. 1, 2. 4.2. So this is a 2S battery, 1S battery, one in series. So these two cells are in parallel. Here I can somehow feel some electronics, so I think it has battery protection. I think so. Let's try and see. So let's carefully remove this thing so I can have access to these parts and check if there's battery protection. Because sometimes the cells, oh, maybe not. No, I don't think it has battery protection. So here you see the batteries, the cells are directly connected on this bar. This bar goes here. But I don't think there is battery protection on this thing. I don't see anything. Because if there's no battery protection, I can tap directly on here, but I need to add battery protection. I don't want to break it. I don't want to discharge the battery. I want to have an external port where I can directly tap on the battery, because I want to have to be capable of drawing 5 amps, which this 5 volt, there is no 5 volt output here, which normally the 5 volt USB output is 500 milliamps to 2 amps, and it is already switching high, so the efficiency is not very high. Tapping directly on it is a lot more efficient. So this, do I need to add some battery protection myself? I need to remove, yeah, I think I have no choice. I need to remove this battery to check if it works. Now, do I want to keep, in the end, do I want to keep, let's test. Do I want to keep this thing full? Do I want to still keep the charger, this main board as charger, or because the battery is easily removable, I'll just use the battery? Let's test it out. And these are huge batteries. Up, 1. Right now I'm more salvaging the battery than anything else. Let's try it out. Screwdriver for tiny screws, motorized screwdriver, because I'm the lazy guy when there are too many screws. The advantage of using this tablet as is that it has the right charger settings for charging the battery, and it has also protection. Can we use the protection from this? So I think this is, I don't know where the charger is. Is there an output port? I don't want to tap directly here, because then we lose the battery protection. If there's no battery protection here, which we will check. So this is the first cell. One. And yeah, generally I use these. You can use anything, but these donor boards are really interesting to train yourself desoldering, resoldering BGA, for example, or fixing stuff. That's almost the only thing you can do with these tablets. Up. Okay, the battery should be able to lift. Let's try to lift it. Let's get one of my spudging tools, but out of plastic. Here. Is the battery glued? No, it shouldn't be glued because it is held using screws. You wouldn't want to add additionally some glue if you add screws. Screws are very expensive compared to glue. Okay, that's the battery. Let's disconnect it. We could use the battery as is. The problem with the battery as is, it doesn't have any protection, doesn't have any case. So if something drops here, it could damage the cells. If I put it inside here, I have a case. Sure, it is larger, but whoop. But it is not too, it is still okay for a huge battery. The size is not really the important aspect here in this project. So now we have all screws here so they don't get loose on the tape. So we don't see if there is a protection circuit on this thing. We could try just to short the ground to the plus, and if after 3 seconds it still continues letting power through, there is no protection circuit, and this bar is just to solder things together, which it really seems it is. Yeah, I don't expect to have the protection circuit on there. Oh, breaking everything right now. I could make a case. So these, I could fold the battery and make a case. It would be a lot smaller. A lot smaller. Do we want to do that? And then just have the external. Do I have a case for it? Would I have a case for it? So we have 2 times the cell. So I don't know if this marking is just for the one cell or for the 2 cells together. I think it's for the 2 cells together. Else they'll probably have the marking also on the other side. More robust shim. Maybe metal is not the ideal thing. I don't want to short everything. Okay, now it's going out. Let's cut it on the side so we can remove the battery from here. Where are my cutter? Here. I have to check if I have a case for that. This really would save a huge amount of weight. So let's be very gentle by cutting. I don't want to pierce this thing. to battery. Oh, there are some tabs here also. Okay. Now the battery should be able to lift the battery up, up. Okay, that's the first battery. There is protection, but not what I expected. Let me try to get it. I need to also remove the second battery. Oh. Okay. Second battery should also come out. Oh, there is protection. That's good. Did I cut it this way? Yeah, I did. Ah, there we have it. There is some protection right there. I didn't expect. And here there are fuses. Ah, because they know exactly how much. So, what you want when you protect? You want several things when you protect the batteries, and this is also what we see on these devices. There are two kind of protections. Oh, actually, well, this is just a MOSFET. This is the thing which protects. So it protects from overcharging, over discharging, and overcurrent. These things are now for overcurrent, being it charging or discharging. This MOSFET, I think, is for protecting from undervoltage or overvoltage. Probably both of it. And yeah, so there is a protection right here. So we could directly tap from this thing. And yeah, if we fold it this, am I allowed to fold it this way? Yes, I can fold it this way without issues. Oh, this is a very compact battery. I think I'll use it this way. I need some kind of case to put this in. They seem rigid enough, but I need some kind of case. So, well, we still didn't convert to tablet for charging, but at least we have another way. And yeah, so we have, I don't know why there are 3 fuses. Maybe one is discharging, one is overcharging, and one is for each cell. I don't know. And this. Oh, this is not a protection. This is mainly probably only to monitor the temperature, which you see here. This is the temperature sensor, isn't it? We will check. 5F62AB or 8F. SF62AB. Let's check what it does. SF62AB. It's a rectifier? Data sheets. Okay, it's not the thing I was thinking of. No images. Okay, that's not, yeah. There's an SF62, but it's not the parts I was looking for. SP62AB, the marking is so small. Let me get my magnifying glass and some lights. Magnifying glass, 10x, and some small lights, which allows me to shine wherever I want to. So what is written on it? SP62AB. Not sure. Here you can probably see it. SP62AB. Okay. What is this part? This is nothing. Other components, data sheets. POC. SP62AB. What is this data sheet? Come on, I hate these websites which only point to all data sheets. SP62AB. What is this chip doing? I think it is just temperature sensor or something like that, or protection. POC, ITM, Hong Kong inventory, no, I don't care about you. I don't know. I don't know what it is, but it doesn't look like a MOSFET, and it doesn't look... It has... Is there some IC? No. Power minus, temperature. What is this? What is the fourth pin? We have power plus, temperature. Are these two the same connection? So I think this is probably just a temperature sensor. Let me probe these two pins. And continuity mode. Let's switch off this. No, sorry, I can keep it. No, they are not connected together. Ah, so there are two. The two parts of. They're probably the two parts of this temperature sensor. Although no, this is the temperature sensor. I have no idea what this thing does. But since we will use the battery as is, let me try to find a case for it. Oh, I do have probably a case for it. Let me find a case. what I can do. I can build a case using my laser cutter and plywood. So yes, it is large enough and I can build a case around that. I think I'll do that. So yeah, we've collected a battery. Okay, we didn't convert this to the power bank. Let's try with the next one. Let's close this device. Here I will keep this as a battery and I will just put this charger on it. So there's the charger, battery protection. I think it's only 3 amps, but that should be enough. Then we have the battery output. That's the first circuit. I'll use USB-C now because it's a larger battery, not micro USB. But this is not important for now. So this goes on the side. This is the first project. Let's wrap it up. By wrap it up, I mean putting this back in. What I could do, yes, what I will do is here, I will cut this part. I will desolder it and leave it here. This way, if I still want to use it without battery, but just with power, just for fun or to test it, I can still simulate the voltage by providing here this voltage. So let's desolder the pins. 1, 2, 3, 4. The other pin is CF. One pin is TH and the other pin is CF. I don't know what CF stands for. TH for temperature sensor, probably CF, I don't know. Which way around was it? This way? Yeah, this way around. Let's put this back in. Who knows who would want that? For now, we just salvage the battery. Not the goal of this project, of today's projects, but we'll get there. One after the other. And yes, my plywood is as thick as this, as these two batteries together. So this two battery will be larger just because of the plywood, because of the thickness of the plywood. But who cares? I don't have any smaller case. Yo, coming at top. And wow, I didn't lose any screw. That's not normal. And you see how useful this small drill is? I'm screwing the drill really fast on it. And when you have plenty of small screws, it's really useful. Okay. Let's put this back in. Let's remove this. These flat flex cables are expensive. Although they're not expensive to make, I did make flat clay. One of my products uses, well, it's not completely a flat flex cable, it's a flat polyamide cable, but there is a stiffener on one side and it is used to simulate, to act as a SIM card. if you want to look at the product, it's called SimTrace. Well, it's the first ever electronic product I designed, and it's very niche, and it's still being sold, not by me, but I don't mind. It is open source hardware. Everyone can use it, and I profit from it. My name and the guy who does it is very thankful and sometimes gifts me things and pays me from some contract work. So I'm very thankful for it. So this is a fail for the project now. We only have, oh, oops, I forgot to add the connector inside. Let's try with the second one. We need to put the connector inside so we could reuse it. Else, I'll never use this tablet. It's really just a donor tablet to have fun probing, desoldering, I don't know, whatever you want to do. It's e-waste. So this one, let's put it on the side. We want to do it again. I need to build a box for the batteries, or not, I don't know. I want to build a box, so I will. Maybe I could just build a pouch instead of having a box, because the box will be larger than the battery. I'll see it. Next one. This is a bit smaller. And here this one is easy to open too. Does it have... Oh, it has an host connection. Meaning it can already provide 5 volt output, which is like a power bank. And somebody already had a look at it. There's a screw normally here. This is missing, like there would be here. So, yep, I'm not the first one having opened it to figure it out, and you see that it is not closed correctly. And it actually doesn't screw anything. It turns... The screw is broken inside, so somebody had a look at it. And probably somebody tried to fix the touchscreen? I don't know. How do I get the screw out? Let's try to open the device without removing the screw. Maybe afterwards the screw will just come out by itself. To use spudgers for it. What kind of i.onik? I never heard of this brand. Okay. Plenty of tabs, and will I be able to open this? Nope, the screw is holding it back. So let's try. How could I remove this screw? Okay, now I can remove the screw. Up, gone. I don't want to solder it anymore. Now I should be able to open the device. Yes, a lot easier. I have to pay attention when I'm opening with this. So this is good because metal is really thin. You can go with a spudger, you can really go inside and open the parts. But because it is metal, you have to pay attention not to scratch the case and not to make shorts inside. This is the disadvantage of metal spudgers. Plastic spudgers exist, but they're a lot thicker. I wonder, do tablets have battery protection? So they have kind of battery protection because they switch off when the battery is off, but they don't have... I wonder if they do have battery protection. Oh, this is also a large battery, 4000 milliamps. Oh, this this looks like budged together. I don't know. It does the job though, but it still looks like budged together. And you see the PCB. There's place here. Let's put some tape. Let's put some antenna. We have plenty of space. This is the main thing, and here the screen. So it is not as tidy as you've seen in the Samsung one. You see that some manufacturers had a bit better designers, but hey, it works. And what I like with this one, so here's the processor. This is probably to shield the processor from anything. Oh, here we have an advantage. So this is the processor. This is probably the touch screen. This is what is broken. Oh, the LCD controller. Oh, and this looks ugly. You see this LCD controller, because it goes to the LCD. Yeah, I think this is the LCD controller. I don't know, Goodix. I've never heard of this brand. This LCD controller, and you see they bought the LCD somewhere, and then the cable was too long, so we just ply it somewhere and then put it back here. This looks really ugly, flexing this cable this way. It probably worked in the beginning. This is the power manager, which provides power to all the things. I really recognize it because it has huge capacitors and inductors. Here this is the crystal oscillator. Under here must be the processor, because we have a shielding thing for not having problems from the processor going out. Well, probably just EM shielding. Here we have RAM. These two bricks are RAM, because RAM is very often in BGA. This is NAND or NOR flash, and this TSOP 56 or 48 package. So you can salvage this and train and reuse this flash, or train to read and write the flash. So this is already good. Here we have an RTL chip. This is very probably for the Wi-Fi. This is RK903. This is probably for GPS, maybe, I don't know. And here we have also some power regulation, or is it, I don't know what this is. Here we have also some power regulation. I don't know what this is for. So questions are NTC. You see the battery, they didn't even connect the NTC. The board, they bought the battery and they didn't even connect the NTC sensor to it, to this board. Up, you see it this way. Yeah. So, no, I'm wondering, do they have this? Does this have a battery protection? So this is, we could again salvage the battery, but this has a power manager. This is the battery output, and it has a battery charger, and it knows how fast it should charge the battery. So this is the advantage. This battery is glued. Is it? Or is it just held with tape? No, it's probably not glued. It's probably just held with tape like everything else in here. It's just, see, this antenna, flat flex antenna, just tape it down. The quality is, that's fun. It's fun. That's, they have a reset button. Oh, this is meant for development. This reset button to reset the whole board with a hole in the back. Even two holes now, just one hole, a reset button. Reset button, you only find them for development boards or things like that. This is I don't know if this is a development board. And having this power reset button populated, I like it. And yeah, for beginners, I mean, if you want to do something for beginners, it works. That's fine. So these batteries are directly probably the cells. There's no charger. So let's open this thing. Oh, they have even more. Whoops. So now it is not EM compliant anymore. I removed the shielding. but this is still, this is metal. This should also do provide some decent shielding. And this probably also to provide some heat. No, this wouldn't be able to provide. Oh, you even have some pads between the NAND, the SRAM, and the CPU. Okay. I don't expect this to be used as heat sink. But was it too close? Did I really have so many issues with RF that they had to add this kind of pads? It's amazing. And here we have a rock chip, RK3066. Yeah, rock chip makes lots of. You find them in TV boxes. They make a lot of CPUs. Really cheap CPUs. So someone did this. Maybe this is even no. GPS. Ooh, we have a nice GPS logo. So this probably has GPS in here. I wonder where though. I see only one antenna, and it doesn't seem to be a fractal antenna which is able to do GPS. And so this is probably the GPS. You see, it goes right here, right to this chip, to this RK903. Let's check what RK903 is. I'm curious. RK903. It's a LAN. FCC ID. That's the chip. Whoa. Let me show you what this is. It is RK. Yeah, already it's a good tip. RK stands for rock chip. And if you look at it, Wi-Fi, Bluetooth, FM receiver in a SIP module. So this is not the GPS. GPS must be elsewhere. So this is the RF. So what is this? If this is the Wi-Fi chip, what is this? I thought this would be the Wi-Fi chip because it's a RTL. So Realtek chip. I don't know. This seems like power for the speaker. This huge MOSFET chip. Don't really know. So yeah, again the question is, do this thing need battery protection? Like overcharge, over discharge, over currents in charge, over current in discharge, and under voltage and over voltage, because it has a charger which takes care of monitoring everything and could switch off this whole board when it meets one of these conditions. So you don't need any MOSFET to cut the voltage because the battery charger takes care of it. This is a good question. And this is, we also we see it here. Let me remove this tape. Here we see the battery plus. I wonder, it goes also to the other side. Here we could have a decoupling capacitor, also a small resistor with here some kind of, I don't know what this IC MOSFET are used for. Is it for regulating, monitoring? Don't really know. But this is not populated, and this has something to do with the battery. This is probably, that there might be some protection. I don't really know. And then it goes also here. So this is the power management for all the cores. It probably does 1.2 volts, 1.8 volts, 2.5 volts, 3.3 volts, and 5 volt output. This is probably the power manager for this IC for the battery. Let's test out. Multimeter. You can zoom a tiny bit more. We're in continuity. Does this go somewhere here? Yeah. So this battery plus goes here. This is probably a MOSFET, or is it the thing driving that? Let's have a look at it. So this is the plus from the battery goes well, obviously here, but it also goes directly here. Then the plus goes through here. This is very probably a MOSFET. Then it is probably be boost with this thing, and this might be the booster. I don't know. So let's have a look at what this chip is. This is an... oh, too much glare. Now let me have a look before I can show you. AP2420. Let's try to find AP2420. What kind of chip is it? For me, it's kind of a MOSFET, which disconnects the battery. AP2420. Nothing to do with that, so Octopart doesn't give good results. AP2420. Data sheet. Data sheet. No, I don't want this panel thingy. Panel. No panels. Do I have to provide the package? DC, here. I think I found it. Chip own. Chip own. Here, this one. I think that's the data. Let this put it back here. Yes, it is this data sheet. It is up here. Synchronous step down. God, step down? And we recognize this package. Oh, this, I don't know, but we recognize the package. And this is a step down converter. 1.8 volts. This provides the 1.8 volts for the whole power. And I wonder, so that's weird. Does this provide up? This is a step down. This provides 1.8 volts. We can probably measure even the voltage. This thing is not on. Let's try to figure out if 4 volts inputs, and let's check on one of these outputs. 4 volts. Oh, sorry, wrong way. This is ground. 0 volts, and then this is probably also ground. I need probably to switch on the device. Let's switch it on. Does it switch on? That's a good question. It says LCD OK, boot OK. Yes, it does switch on. Powered by Zertizer. I don't know what Zertizer is. Let's boot it on. I don't know if I booted it once because it says boot OK, touch KO. i.onik. And the LCD has a broken line. And yeah, we have to set it up, but we can't set it up because the touch is not working. But let's measure the voltage and let's find the 1.8 volts. Not here. Here, 1.2 volts. Was it 1.2 volts? 1.2 volt outputs. 1.2 volt outputs. Did it say 1.2 volt on the data sheet? 1.8 volts. Well, it's a step down, so you can. It's a step down converter, buck converter. Don't know if there are other step downs. Well, it's a buck converter, so you can probably. It's not fixed, is it? Output voltage from 0.6 volts. Okay, so they use it to have 1.2 volts output. And you see it from the output here. No, it's more than 1.2 volts. Maybe there's some 1.4 volts, 1.2 volts. It's wiggling. 1.3 volts. Okay, so this is just one of the outputs for the device, and when it is off, it doesn't work anymore. But so this chip, does it also tap directly on the 4 volts? Let's switch the thing off. Let's keep the button pressed, and after 15 seconds, yeah. Oh, you even hear a click, meaning they don't switch off the audio driver correctly, because you hear the click when it switches off, and it means it cuts the power from the thing. Yeah, it's hard to have everything correct. So let's try to find where the 4 volts also go. Continuity mode, because this 4 volts will probably also go somewhere around here. Not this one. It beeps at the beginning, but this is just because of the charging. Then it's off. Here. Here we also have the connection. Oh, here and here, both of them. These two connections are connections to the battery. And this is probably, looks very, I don't know this logo though. So I will add this logo to my open source hardware logo page. AXP202. AXP202. This one doesn't have a logo, AP, but I think the chip doesn't have a logo, so I don't mind. AXP202. Yes. Oh. X power. Let me put this back here so we can have a look at this. This is the AXP202. USB compatible PVM charger, buck boost. So this does all the regulation. What is this? Single cell battery PVM charger and power systems. Yeah, as expected. This takes care of doing all the work. But X power, that's AXP, yeah, XP, X power. Why the A stands for probably advanced X power, or just because you want to be on top of the results if you sort the results alphabetically. Might be one of two. I need to drink something. I'll be back. And here I'm back. Ah, that was necessary. So this does it also do the voltage protection? Well, probably yes, because this is a single PVM charger and power management here. So this probably also has some battery protection. Designed high integrated for optimized for single cell. Multiple outputs, yes, it has tons of output probably. 2 buck DC converter. So everything runs at buck. You can also have 3.3 volts. 5 LDOs for the buck converters. So the LDO is probably for the 3.3 volt output, and the buck converter. Let's try to decrease the size. So the LDO is probably for the 3.3 volts, so you have something stable, and the buck converters are probably for the everything which is 1.8 volt or things like that. Can distribute externally battery, high power, single cell adapter, programmable. TVI interface, 2-wire serial interface. This is very probably I2C. You very often, I think Atmel calls the I2C 2-wire interface, so they don't put on the trademark of I2C. I don't know who owns I2C. Does it have protection? Does it have protection features? Here, intelligent power select. Okay, charger, I don't care. Signal, host interface, I don't care. Battery backup, okay. System management, low dropout regulator, high integrity. Protection. 2-level low power warning and protection. Over voltage and under voltage protection. So it does take care of it. Over current protection and over temperature. So yeah, it takes care of everything. Now, can we tap off this thing? Can we use the regulated outputs? Does it have a pin for the... Let's have a look at the pinouts. How do I want to do it? We will have a look closely at the sheets. So up. Sorry. When I switched to main screen, I didn't have the right microphone enabled. Sorry, I spoke a lot, so you didn't hear me for a long time. Very quick summary. Yes, it has protection. You see here battery protection and so on. What I want to do is, here we have the pinout. I want to figure out if there is a protected battery output. This is the battery input. Temperature sensor. Here we see battery sensing, voltage in. I don't know what this exactly is for. Here we have the first buck converter, second buck converter, plenty of LDOs. This is the input. This is temperature sensor. You see it because it has a resistor which is variable, 10K at 25 degrees Celsius. This is the resistor. IPS out. I think the PS out is the pin we want. This is where the battery is output and it is protected. And we see that 3839, we need 2 inputs because we can draw a lot of power. And here we have 2 pins also, meaning it can also draw a lot of power. AC is just to charge it. AC in is the adapter charge in. Also 2 pins because we charge at 2 volts, 2 amps. Ah, and there's somebody ringing. I'll be back. It was just a friendly neighbor getting the package. So yes, AC voltage input, this is the maximum rating, but it wants something like 5 volts input to be able to charge. And it says it charge at 2.5 amp. Although the i.onik says it's 2 amps. I saw somewhere 2 amps. Voltage input here. Voltage input, it says 5 volts, 2 amps. And this charger says that typically it's 2.5 amps. So there's kind of a mismatch. Or there might be a regulation. It might be programmable how much it draws. And yeah, what I also wanted to say here, SDA SCK looks very much like I2C. We see 2 pull-up resistors, 2.2K, very often used for I2C. 4.7 and 2.2 are the most frequently used pull-up resistors. And then, yeah, and here we see the I2C address or the TVSI address. So they call it TVSI just to have no issue and pay no fees to use the I2C protocol. That's fine. Now I want to figure out the pinouts. Here, pinouts. We had 35, 30 here. Main battery. Input, output. I think this is the regulated. And this is the output main battery. This is the output. This is where we want to tap very probably. Let's say what it does. VBus battery. This is the output. Here, when provided, PC will fall and the battery. Oh, the datasheet is not bad. VBus management. Bits. Okay, this is now we are in the I2S protocol to program everything. We don't care about it, how it is programmed. Pin description. Oh, power output on off switch. Ah, so if it's not on, I don't have the output. Do I want that? Do I want to always tap on it? We can try if it works. So now it is off 34, 38. Where is the input? Where is the output? Ah, this is probably what we measured. Where is 34? 30, we had a diagram with the pinouts of the chip. Battery here, and then this is the outputs. Let's have a look. Where is pin 1? This is marked. Pin 1 is right here. So here is the battery input. This is this one. This is the voltage output. IPS out. Now the laptop is switched off. Let's go to voltage and let's measure the voltage, the output voltage on this thing here. 4 volts. So the output is there. So this thing is probably in standby mode. It is on, and probably if we drop too much voltage, this probably switches off. Also this output, because it told in the data sheet that it can switch off the output. Where do we have it? Here. This is an input to ask for the power output on off. Our lab thing is off, but we still have ground on. Ah, no, I didn't. I understood it wrong. Sorry, this is another pin. This is. This only means that it is. Yeah, output enable, and then the N means negative, so it is active low. This is what they mean here. Ground is on because it is active low. And if it is high at this voltage, then it is off. It's not superb how they did it, but I think this output is protected. Main battery, yes, I hope it is protected. Here we have the IPS with the output. This is the protection system. So we can tap directly here, and then we have protected battery output. So we need just a cable here, and we need to output it somewhere, and then we have a charger. So this is the first project where we can really use the tablet with the right charging regulation and so on, and tap directly, so we don't need to provide a charging regulation. Although this one on this project, another solution, let's go back to the bench. Can I increase? I think you are seeing the thing very dimly. Maybe it's my screen, I don't know. Because this has a lot of space, I could use it a bit differently. Now we figured out how this works, but we could have it use it differently. We have tons of space. So what I could do instead of using this thing, of using this battery management, is up. So this goes here, and use something like this. This is what you very often find on batteries. This is battery protection. You see here again is the chip for, like here. It's the same principle, and it's probably the same chip. These two things. This is a transistor. This is the IC. Is it the same? DW1. It's not exactly. Oh, it is. No, it's not. It's not exactly the same, but it's very similar. But it's the same principle. And this chip is there to protect against over voltage, under voltage, and over current, under current. This is what this chip is done. This is what you put on cells. And because we have tons of space inside, because it is not very compact, what we could do is put this inside, just next to it, tap on the battery voltage, and then go outside. Then we have the battery, which is protected thanks to this board, and we can charge it externally, or we can use this charger, and this is kind of robust. Because we know we found this out, we don't have to use it, but this would be a complete viable option, and maybe we will use this option on our last thing. We will see. Here we found really the output, because it's not very integrated, so we will use this. And I like this also because I want to not disconnect the battery, because it has a host output, so we can put USB devices in there. So we will tap on here and use this ground also. This will be our plus cable, and we will have a lead going out. Where will it go out? Where does... Here. I'll probably have an output right there. Maybe somewhere where I don't need to put holes inside. Here would be ideal because I have plenty of space to route the wires. I could have it also oh, I know what I could do. This is where the screws should go, but I think the screws don't fit on it anymore. They have, at least on this one side. On the other side, let's try it out. Does the screw fit? If not, I will just use this to put the cable... Ah, no, I can't, because then I cannot open the device anymore. Now you see? Yep, it went in without me screwing. So this is already busted. This is not busted. We can use this one. No, it's almost busted. Ah, it's almost busted. So we can't reuse these, we'll just rely on the tabs. So the cables, I want them to have the output here because this is also where all the other parts are. I'll probably have the output right... Ah! This is busted, so I can use... this is a bit too thin. I think I will have the cables here, so I have enough space. I will just scrape this, make a hole here, and then have a wire connector here, the battery connector here. I think that's how I'll do it. So this seems light aluminium. Can I do it with a file, or do I need to get a power tool? Let's try with a file. Oh, it's very soft. It's very soft aluminium. I can do that with a file, and I'll do it with a file, so it's precise. I'll not do it on the table because it will shake the whole table, and the camera you're seeing is mounted on the table. You see how soft it is? Let's do it up until the end. I'm just using a regular file. Okay, this looks good. I could use all the... I could retap... Oh, this holes look completely broken. I could retype the holes for the screws and put other screws. Right. I think it has enough tabs on the side. It was hard enough to open. So this is the first side. Let's mark the other side. Let's write here. Marker. What I don't like... Oh, I didn't find any good solution. This is white marker. I think this is chalk marker, but I don't find anything with a really fine tip. I found some with balls and fine tips, but this doesn't work for metal. And plenty of plastic is now black. And because it is black, I can't mark on it with a normal white marker, dark marker. So this is this. Yeah, here we see I have plenty of space to route the cable. I'll put the cable here, go down, go here. Yeah. Could also route it here, but there's less space. So let's do it here. I could cut it with some plier instead of filing it. But filing it gives a nice finish. It takes a bit of time though. More than the... Yeah, you see, as soon as I do it, it shakes the camera, which is not very good for viewers. For me it's better, for you it's worth. So the plastic is harder to file than the metal. Is this enough? Probably not. More. Oh, maybe it was a bit too loud for you. Sorry, I had to blow on it. Okay, the hole is made. Now this should fit, oops, all the way around. This foot should fit nicely here, and then we have the power output here. This works quite fine. Maybe I should just remove, to make it a bit brighter, I should remove this ESD mat. That's also a good solution. Let me do it, because I think what you're seeing is really not very bright. And the ESD mat, no, I keep it. You have to get used to. Next time I get a ESD mat, I don't get it green, I get it white, even if it's, or gray, even if it's gets dirty, it puts more light. So let's solder cables. Soldering iron up. Let's use again AVG20 cable. Let's prepare it. AVG20, that's one side. This is the battery. Up. Up. I'll put some tape back here because this is aluminium and I don't want it to touch here. So like exactly like they did, I will put some polyamide tape here. This tape. So soldering iron should be ready. Let's tin the wire. Up. That's tinned. Let's try not to make a short, but still. How do I want to put it? Do I want to add it this way? It's also too large. Let's cut it a bit shorter. Up. How do I want to add it this way? This way. Nope. Oh, huge ground plane. Let me heat up the ground plane. Okay, this is ground. This will sneak around here. Go to this output somewhere around here, and here we'll have. Can I build in the connector? Let me check what kind of connectors I have. Maybe I can even have the connectors on it. I want to use a power connector. I think the power connectors are here. Let's see if it fits my box with power connectors. So here, power connectors. And I think I have battery. I know. These are too large. They they won't fit. Let's put it somewhere here. I do have other connectors. I think, where are they? I have this how are they called? XT connectors. These are from the RC world. Quick Connect terminal. Is it this? No. Not USB. PH connector. No, that's not it. RCA. Maybe they're really in here. Ah, here they are. That's what I meant. These connects are XT30, XT60, but I think I also have XT30. Yes, here. XT30, they're smaller. Do I have some? Yes, I do have. They're here. Can I fit an XT30 here? That would be really nice. And you want to have this side? Or this side? Probably this side. Which one goes to the battery? Is it this side or is it this side? The advantage of having this side is I can really put it in here. And then, yeah, I could put it in here with the power output. Or the advantage of, there's this camera. Yeah, I can get rid of this camera. I will never use it. So I'll probably add this connector and then I can just, with the pin, go in here. The problem, yeah, I think we will have this connector on here because this connector has the issue that if something metallic comes inside and makes a short, then you short the battery. So I think this is the battery connector. This is the plug connector. Will the plug connector go completely in? Or do I have a stubby output? Stubby output is also okay. The connector is long enough. Then I connect like this. And we have a nice power output. I think I'll do it this way. I have to enlarge the hole a tiny bit on this side too, but it's completely doable. It is completely doable. And yeah, I'll have this a bit sticking out, and this way I know I have an output. So it goes. Let's leave it a bit longer, but for now this is the one side. Let's try, and here I have to put epoxy and to on it and not hot glue because the forces to plug in will be a bit higher. Let's use the file and enlarge it. And we have to enlarge it. We don't care about which side, and we have to make it go down. Don't blow on this thing while I have the microphone on. Don't forget about it. I think this explodes your ears. Tiny bit more. I'm too lazy. No, I don't want to get the Dremel out because it makes too much noise. So instead of blowing, I will get here. This is what you could use your toothbrush afterwards, cleaning up stuff. Does this fit? Yes, it fits. It fits nicely on there. Would be nice to have it a tiny bit lower. Ah, the camera is shaking. This table is not stable enough. You understand the S table? Huh? Nice pun. Or not. Yep. Okay, now this fits nicely. Does it fit on this side? Oh, no, I have to get plenty of metal off. But it is really soft and the file is biting in the metal very easily. Takes me seconds to complete it a bit more. Now it fits. Can I close the case? Let's just close it on this side. It's not perfect, but I can close it enough for the clip to be there. Now, can I plug this in? Yes. It is a tiny bit loose, but it does work. Yeah, it is a tiny bit loose. Oh. It's not, we lose 2 millimeters here. It's quite a lot. Ah, it's not completely in there. So as soon as it will be here. Oh, this is fine. This is fine. Ah, maybe it wasn't able because, yeah, I have to scrape even more metal. So on both sides, they're not in the way. It's not in the way. Up. Yeah. Now I can close it. And it's not in the... no, I get what. I can't completely close it with the connector because of this. This is too high. Ah, that's good enough. It will push on it. It will give stability. I will add kind of a screw inside here. Probably the screw I had, which I lost. No, it's still here. I will re-add this screw in here. But for now, let's connect the cables. Up, this is minus. We have plenty of space in the case, so I can keep the cable long and then sneak around. That's fine. The cable is AVG30. It's capable of having plenty of current for these 2 centimeters more. And up, this is black. And for the plus, I will not use the red color. I will use the yellow color because red is for power directly. We are not using the power directly. We are using the output of this voltage regulator, of this IC. So let's solder the minus on here. Which is plus, this is plus, so this is minus. So there is a well inside here, so you just heat up the well, put some solder in the well, heat up the well again so the solder flows, and then come with the cable. There's not... Okay. This is holding very firm. Ah, it's warm. It's holding firmly. Oh. I didn't think about that. This cable should be flexible enough. Thank you, multi-stranded cable. This is the first pin. Let's get the second one prepared. This is minus. It must be short enough just to connect to the capacitor. We want to connect to this capacitor. This is the IPS out of the chip. So let's also add some solder here. Let's try to not make any short because the battery is connected. How do we sneak around? Do we sneak around here or do we sneak around this way? Let's sneak around this way. Okay. That's fine. Now we can sneak. Yeah, we have enough height. You see the chip on there. We don't have this shielding on there anymore, but I don't think it matters too much. And we can also sneak around. I'll add some, like they did, I will add some tape to fix everything together. Oh, this is not me. Is this me? This tiny solder ball? Gone. This connection should be fine. Don't know how much I can draw outside of it, but this should be fine. So here will be the battery plus. Here. I should measure it. If it works. That should already be 4 volts on the output. So we are on voltage. Oscilloscope. This is one probe. Where is the other one? Here. Probe 2. So minus is here. Plus. Yes, we have 4 volt output. And it comes from the battery. And I don't know if they programmed inside here how much current can pass through maximum before it switches off. Oh, that's a good question. I don't know. Up here there's the well. So let's heat up the well. Put some solder on it. Up. Where is this cable? Yes, this looks fine. Up. Connector is going here. The cable is going along here. That should be able to close. We should be able to close it. Let's put some tape to hold everything together. This is no. Ow, ow, ow. Hurt myself. And 3. So we put this. Then we absolutely need to protect the battery. These are the cables, and we will put some tape here. Let's measure if we still have 4.2 volts on the output. That's minus. That's plus 4 volts. That's the output. So now I will prepare some epoxy, 2-part epoxy for this thing. So here my 2005 2-part epoxy, which is hard after 5 minutes, so we need to be fast. I need some paper. I don't like it because there's one part which is really fluid and the other part which is really hard. Whoops. Let's get some epoxy out. You see there's the left side now which is oozing out, but not the right side. And now the right side is oozing, but slowly. And I'm too impatient. Let's mix it. Already, yeah. This is not high quality epoxy. I've had better. Don't like the blob it forms. Would love it to be a bit more fluid. Okay, there should be enough of the 2 parts. Let's mix it and act really fast because this gets solid really fast. So let's put some epoxy on the bottom. Of this. Insert, don't touch it with your fingers, and you will have plenty of epoxy on your fingers. It should go on this way. Okay. Now let's put the rest of the epoxy on the back. Maybe I didn't make enough epoxy. Yeah, I need to buy some better epoxy. This is already string. I want it to be a bit more fluid for the first minutes. Not that hard from start. Okay. I'm sure there's not enough epoxy right here. Here I see a tiny. Let's stretch it. Okay, let's wait 5 minutes. Here we have a witness epoxy. If this is hard, this should be hard. But this epoxy hardens really fast. Let's check again if we have voltage outputs. That's plus. That's minus. We didn't check how much current we can get out of it. Yeah, we have 4 volts. So this works. And if I connect, can I connect this? And let's wait for the epoxy to harden before we press on it. We have to wait 5 minutes, and what we can prepare is the other side. So on the other side we will have the battery directly. We don't want to charge. I will mark it on the case that we cannot charge it this way. But what we want to have on the other side is kind of a transformer, so we can have plenty of voltages, but we don't want to have... Oops, wait. I have this transformer voltage regulator. Here on these voltage regulators, this is my voltage regulator box. Sorry. Here you have an overview, voltage regulator box. Last time we used such a voltage regulator, voltage booster. The problem with this one is you don't see the voltage output. What we want to have is one where you see the voltage output. And I think I have one, but not in my voltage regulators, but somewhere here. Exactly. This, I think this is... Oh, is it step down or is it step up only? Damn it, it's only step down. So I don't have a step up with a voltage thingy. This is only step down. We want step up. Do I have a step up with voltage? Else I'll have to make it. No. Nope. No step up with display. So what I will do is make a step up with a display. Let me get a display. For that I need to remove the microphone. I do have some boxes stored away which I don't use very often. Here we have my voltage meters, DC meters, and we can use one of these tiny things. That's here we could monitor the battery voltage. So this could be the input. This is 1S, right? 4.2 volts. So this could be the input voltage monitor. And what is this? LiPo. Yeah, we have plenty of them. We can use this for the inputs. For the outputs, we can have something like this. 200 volts, that's a lot. Don't I have something smaller? Do I have something larger? I have nothing smaller. Here, these would be better. 50 volts, that's nicer, but it's huge. That's calibration. And what is this? 100 volts, 10 amps. This would fit better. 200 volts, 10 amps, we will never have 10 amps. 50 volts, 5 amps would fit better. We could use this, and then we could solder one of these voltage regulators on the back. I'll solder. Where is it? It's this one. There's enough space for having the voltage regulator on the back here. And this display output for 1S. Up. LiPo level. Up. Voltage output here, and this can carry 3 amps or something like that. I don't remember which one, how I did write it. No, it's the wrong one. On the box, yes, 3 amps. And then we have here, yeah, I think we will use this. So I don't remember why I got this. Maybe for project like I just did. Oh, it needs at least, it to operate, it needs between 7 and 12 volts. Not good. Let's test it out. That's okay. Let's use this power meter. Let's try to figure out when it starts. Off. We don't want this high voltage. Let's go down. So these are the inputs. This is the input voltage for this module, and let's test what's the minimum voltage it requires to switch on. So if it's too low, it won't give good results. But yeah, I'm not too worried about it. Here, clip minus. This we can put it on the side for it to solidify while we work on this tiny project. So let's set the voltage to starts with 2.3 volts. Okay, did it disconnect? No, it is connected. 2.3 volts, no outputs. You should probably also see, don't you see it? It is connected. It is showing that it is not on, so it is broken. It seems that the software breaks from time to time. Okay. Amps. Let's switch it to 300 milliamps. So voltage, let's increase it until it starts. Five volts, it still doesn't start. Now it starts. 6 volts. And it becomes clear at 7 volts. So yeah, 7 to 12 volt output. This is the minimum. So what we need to do is connect this to the output. And the problem is that this is maximum 12 volts. It's not ideal. The other one I have. What is the input and output voltage of this one? This one is smaller. It is 200 volts, but if the voltage is lower for the start, it fits better my need. So again, we have plus minus. This is the sense line. And I want it to go up to, so this is up to 12 volts input. I would love it to go to 20 volts maximum input. This, if I would use, if the 7 volt would be the minimum, I would have to use the output of this voltage regulator. But if it's the output, it can also vary. If it's now working with 3 volts, let's switch the voltage down. We can just connect it to the battery, and it will always be between 3.7 and 5 volts. So let's switch it on. On. This is 1.8 volt. It's not on. Still not on. Yes, 3.6 volts. It switches on around 3.5 volts. 3.4 volt, it switches on. That's perfect. That's what we want. And if I connect it here, it should tell me the voltage. 3.34. Yeah, it's not exactly that. It's 3.4 volts. But it's good enough. And I'm surprised by the resolution of this amp having three things. So we will use this small module for measuring the output of here. This will be connected to the battery. And actually what we can do is instead of measuring, so we could use this for indicating the voltage of the battery, the current state of the battery. What we could also do is have a small switch which actually connects this to the battery voltage instead of to the output voltage. And this way we can check the battery voltage and we know that it is, yeah. And this way we save the space for this module. So we just have to put things here. The disadvantage is that I need a screwdriver always to change the output, but that's okay. That's the output, that's the load. Here we can set, there are two trim pots. I think this is to calibrate the values of the current and the values of the voltage. So we can really calibrate that. And to keep everything small, I would love to bend this. I would love to, or maybe here on the side, this way. Then we have all the wires. Or on the back. I don't know. What I also have another thing. Well, it's something else. Yeah, it's another project. I'll still show it because it might be useful for you. I have to get rid of the microphone. What I also built is this box. This is a buck boost converter, and the advantage is that you can feed it whatever you want on the inside, and you can go up to 30 volts, down to whatever you want. And the problem with this one, it cannot operate with a battery. It needs at least 4.5 volts or 5 volts to work. Well, 5 volts at least. Yeah, this is what I wrote here. 5 volts to 30 volts input. So either using one of these barrel jack or micro USB or USB-C. And this way you can connect inside here, and with USB-C you can provide any voltage you want. Normally 5 volts, but you can provide more. Here you can provide up to 30 volts. And then you have an output which allows you to, so this is a portable power supply, and you can set the voltage and the current. It's not very powerful, but it is very small and it works, and it's buck boost, so you don't really care what you put inside. And you can use any kind of transformer or any kind of laptop power supply. But we can't use it. That would be nice because it shows the input voltage and the output voltage. We can't use it because it needs at least 5 volts. We don't have 5 volts with battery voltages. So we will use this and this. And if we want to switch it, then we have to turn this potentiometer. And how do I want to put it? Do I want to put it here? Do I want to make a case? I could make a case for this small thing. Or do I really want to make a case? Not sure. The case would take, it's so small, it would take too much space. Yeah, ideally you would fit this right here. That's the right size. So let's try to change that. And let's have, oh, this is this way, okay. This is this way, plus minus, it's written here, plus minus, that's written, yeah, that's written on the board. So, can we fit it inside? Oh, it fits inside. that would be ideal to fit it inside. First, we need to kind of bend everything. So we need to remove, let's get the desoldering gun warm. We need to remove this connector, and solder the cables directly on it. And then we can put this somewhat inside enough. Here, we could put this somewhat inside. In would be where the power comes in. Yeah, that would fit nicely. Let's break. Oh, this is broken. Yeah, it fits almost perfectly inside. But this bar, we need to kind of change it, and these tabs we need to, although we don't need to break the tabs, we can keep the tabs, they work in our favor. Let's open this thing. I don't remember where I bought it. Just look for 200 volt 10 amp meter on AliExpress with 4 digits. You'll probably find it as fast as I could. And you even have, so this is one of two things. Either it is STM8, which I think it's not, but it's the pin compatible version of the STM8, which is the Nuvoton N78 something, 76 something. I don't remember. I did program it. N78, 876. No, it's the pin compatible version of the STM8. And it is really inexpensive. Already the STM8 is inexpensive, but the pin compatible counterfeit, not sure. And the pin compatible version has also some advantages. I don't remember what. Not all the pins are the same, and you cannot program it the same way neither. But here is the programming header for this chip, and I think even debug header, there are too many pins. There's probably also a debug outputs. I don't know what these things are. They probably select options. It's a good question. Okay, that will be a pain. Here you see, I want to desolder this thing so I can solder my cables directly on it. The problem is that to desolder it, to have access to the pins, I need to remove the LCD. I don't want to do that. So we will desolder it from the front. So we will remove first the plastic. Let's have some things. We can be destructive here. I don't care. And we will desolder the pins from the front here. Plastic gone. This is a bit harder. Wiggle, wiggle. What we could do is heat up. Okay, it works. If it doesn't work, you just heat up the metal. At some points, it will be so warm that the plastic will melt. And now we actually don't need a desoldering gun. Let's switch it off. Because how we do it, although we do it, let's keep the desoldering gun to clean up the pads. What is this chip? Ah, this is the comparator. This is to measure the current. So to measure the voltage, it's probably just an ADC. And this, either it is a comparator or it is already an ADC. For 4 digits, although the STM might have, no. The STM might have just an 8-bit ADC built in. Maybe the clone has a 12-bit ADC. There 4 digits would be enough. What's written? LM. Okay, it's an LM3 something. So this is an op amp or a comparator. Oh yeah, an op amp. So it's not an ADC. Wiggle, wiggle, wiggle. Almost done. Now we're done. And now we can desolder the pins. The soldering iron is ready. So let's not use this because this would remove too much heat, but let's use ceramic tweezers and just heat up the pin, and the pin will have enough energy at some point that you can just you see it goes straight through. And this is how you could desolder. Next we can solder the things on it. Here I'll use it, so let's do it also for this one. This one is a bit harder because you see the copper plane is a bit larger. Well, you somehow see, but it still works. 1, 2, up, and we will use the desoldering gun to get the holes clean. Okay, it doesn't work. Good enough. Up, up. So there will be this module. We also need to bend this. Oh, this is warm. We need to bend this so we can fit this on top. It's almost the same size. It's not completely the same size though. Almost. Does it? Yeah, it would be ideal if it fits like this. It's not completely inside. And that's good enough. So here is the, no, we can put it this way or this way around, it doesn't matter. What we need to do is bend this somehow. This is rigid copper. Then we'll have bend on the side. That's okay. Pliers, and I don't want to break the board with my bending. So let's have this hold here, and let's have the larger plier try to bend it. I don't know. I do not want to break. Oh, what we could do is desolder it and resolder it on the side. Or we could reform it. Not having this way, this is useful for hand plugging, but we could put it wherever we want. Do we just bend it? It needs to be this track, between this track and this track. That's all it needs to do. Could we add it? Is there enough space to add it on this side? Let's measure it. Up. Tweezers, calipers. This is this much. This much doesn't fit under. No, it could. It does fit under. Let's try it. Let's try to fit it under. And then solder it on. Yeah, we need to calibrate it, because if we solder here, the resistance will be a lot smaller. So we will have to calibrate it, which is okay. Do we want to do that? Yeah, we'll try it. If we could fit it under, that would be ideal. Ah, for that I need a heat gun. Here there's too much solder. And it's already, no, it's not too... Heat up, heat up, heat up. Can already try lowering the volt to heating up this. Not sure if the nozzle is large enough. Let's try to... Oh, there's a second here. You see there's a footprint for a SMD resistor. It'll never work. So now I'm doing bit by bits, and I'm pushing out this thing. Oops. Don't hit the camera with this. Oh, it's warm. Don't hit the camera with the soldering iron. There we have it. Now this is warm. Oh, both are warm. Whew. Let's have it cool it down, and then we can try to solder it on the side. Up. Don't touch it and let it cool down. The soldering gun should have it as complete. Switch off because it's loud. So this... Okay, this is touchable. I need to... Here, this way. Here we yeah, we can fit it on the bottom. I need to... Yeah, these corners here, which are normally for mounting on the board, they are in the way, so we need to remove them. Let's knock them off. Okay. And yeah, we could solder it here. It would be a really tiny trace. Ideally, I would not want it to be that small. Still want to have a large trace. Or is it okay? No, it's okay. Or we could have it on this side. That's possible too. No, we want it on this side, and we will calibrate it using this trim pots. Let's have it this way. Let's try it out. It touches the pin. Now it doesn't touch the pin. That looks doable. Maybe I just put it on the side so it doesn't touch the pin. This way it is crooked. It is really crooked, but it doesn't touch the pin and it's still inside. Actually, could have it just a link here. Or just have a solder tab or kind of a wire here. But since we won't have a lot, yeah, we could actually do that. Instead of using this, we could have a wire here which has this resistance. What is the resistance of this? What is the resistance of my leads? Do I have something to measure that small resistance? I'm not sure. Let's try it out. I do have something to measure. Is it for tiny resistances? I do have something to measure. What is I think it's just an LC meter and not an LCR meter. LC meter, not LCR. Okay. This won't be able to measure tiny resistances. This might be able to. Let's use a multimeter and figure out if we can measure the resistance. Here, multimeter. Let's put it on ohm. You have to null the resistance first, so this should be 0. It is 0. 0, 1, relative. And now if we measure this, what is the resistance? I think it's super low. Yeah. It's like 0.1 ohm or something like that. It's really tiny. Yeah, what if we just put a cable between these two pads? Would this work? We can try it out. Let's try it out. Let's have some fun. If not, here I have some wire. I don't know what this wire is. Probably the resistance of this with this short is probably equivalent to this. I have no idea. We can just try and then calibrate it. No idea what this is, the resistance of this. I would say 0.1 ohm, but I don't know, and I have nothing to measure such tiny resistances. How we could do is just put a lot of current through it and measure the voltage drop. I don't have enough current. My power supplies can deliver safely 5 amps before they are in a constant current we're able to measure. So let's just try it with this. We'll test it. So good job, bro. Good up. Oh, there's someone who is looking at the stream. Thank you. Let's cut it. Now, where is my cutter? Let's have a tiny wire. I'm not sure what the resistance. I even don't know what this wire is. I don't know what the material is. I have no idea what this is. We'll experiment and we'll have fun. Let's put some solder. one side. The other side. Looks like that tiny resistor, right? Well, let's check if we can change the current. So, I don't have the pins to do anything anymore because we desoldered all the pins. We can solder some tiny pins here or some cables. I would like to try this out before. Do I want to solder some cables? I don't want to. Do I have to solder some cables? Maybe. Oh no! I can just clamp. Where is here? I can't clamp this. Here, clamp it. The camera is shaking. I have to fix the camera somewhere else because every time I move the table, it moves. So normally I can now let's switch it off, and I can put a constant current inside here, and now I just need to provide some power in here. Let's use the other power supply. There's too much stuff on this bench. I have no idea how other people do it, or how others do it to keep the space on the working bench. Don't know if someone has a good solution. This can go here. Keep it clean every time you use something. That's completely undoable. Or just don't do anything. That's doable. Then you don't create a mess. This is minus. This is plus. Up. If we switch this on, let's set the current lower, not more than 100 milliamps. Up. Okay, this is on. And currently it shows that 23 milliamps are going through here, which is really not the case. There's nothing going through here. Let's put 2 amps, 200 milliamps. Now there's 204 milliamps, and it says 18 milliamps. Can we turn it enough so it says 204? It's this thing. Not the right tool. Let's first mark how it was. Okay. This was here. So let's try to increase. Do we measure correctly? 200 milliamp is going through here. Yeah, okay, now it says 0. Okay, it's not able to measure anything. 11. That's the minimum. We've reached one side. Let's try the maximum on the other side. No, there's nothing there. There is 200 milliamp going. No, this was right. Why doesn't it show anything? If we put... No, we don't. We can't now. Not enough resistance. Oh. 200 milliamp. I didn't test it before. I didn't test if it worked before. Maybe it didn't show anything intelligible. That's completely possible. Maybe it was completely wrong. Let's test it. So let's solder it back on. Let's switch this off. Let's solder this back on it. But in a way that I can desolder it really easily. So on the side. On the side. On the side. And I don't want to touch it. I will burn myself. Up. Let's put some solder. One side, the other side. So now we have the original thing again. So now it should show 200 milliamps if 200 milliamps go through it. Plus, minus, switch on, this works. Now I have to connect plus here, minus kind of here, but I can't hold it. Can I put it here? Let's try it this way. Oh, it shows. Yeah, it does work. It shows 180. Well, it's not exact, but also because I'm not holding it where it should be. If I put it here, it says 225. This is close enough, and we can tweak it. We have to tweak it, but this is close enough. So maybe we have to keep this part because it works with this part, and we just have to. Oh, I just can put it the other way around. That's also possible. Hide it, but down. Let me not burn my fingers. Up, up, up. Up, up, up. The issue I had is that if I use this way, we only have the short lead, but I can turn it around, cover it in a tiny bit of tape so it doesn't make contact with anything else, and then solder it this way. That's how I'll do it. And then I can put it inside. I could add shrink tube. Yeah. Then I can solder it this way. Then we have the right value. Here, I solder it like that. Oh, don't touch the leads. I solder it like that. So let's do it this way. Solder it like this. It's still a bit too long because of the leads of this thing, but it's a lot better already. We can trim this side tiny bit. We don't have to. We just have to make the hole a tiny bit bigger, tiny bit larger, which is easier with the soldering iron. But for it not too short, we will first have to put shrink tube on top of it. So shrink tube box. This is too large. Don't I have already such a thin thing? Too large. Not large enough. Let's use the too large one and shrink it down. Is this the same thing as this? Seems to be. Let's try to bend it around. Doesn't want to bend. Do I want to? No, that's too hard. I could straighten the metal up and then return it, but it's too much of a hassle. What I'll do is pull on it from one side and then pull on it from the other side. This way. Maybe what I could do, yeah, let's do something else. Maybe this works better. Let's have a small parts, and let's see if we can put it completely through. Yes, one. Then we have two more parts. 2 and 3. They're probably both long enough. So let's heat shrink this up. Hot air gun, 200 degrees Celsius, and not long enough to burn my fingers. Okay, this is protected. We need to protect the two other pins. Up, up. One. Let's heat it already, so it can't go away. And the second one is a bit too long. Let's get it. Let's put it in. Okay. Let's hold it and let's heat it up. I don't know what happened to the hub, but the hub is now completely almost dead. There's nothing on it anymore, and it just made the my audio recorder always restart. This hub is kaput. At least kaput. Oh, I know why. Maybe it's maybe not the hub, but something else. So the last feature, this small heatsink will be the last feature. We'll go right on here. I'm not sure if it will help a lot, but it's fun. And this is done. This works fine. And let's test if it actually works, if we can use this to power our how is it called? HF receiver, UHF receiver. Let's test it. It should be okay, but because yeah, it should be. I don't know. Let's just test it. This receiver just draws 500 milliamps, but 300 milliamps, but still, I don't know if this can work. So first connect this. So 12 volt outputs. Let's try to connect here and see if the 12 volts can be maintained. Okay, but this was not starting. Let's now switch on the UHF receiver. No, let's let it charge. No. The hell? I have no idea how little it can sustain. And I'm not sure. Let's try to switch to input. I did cover them. Damn it. With the glue, I just glued shut this. It doesn't check the input. Maybe this is limited to 2 amps output. I don't know. We should try. Let's first fix this and let the thing be able to. No, it's not limited to 2 amps. I mean that's not the issue now, because if it would be limit, or it would be over discharge current, then it would shut off completely the battery, and it didn't shut off completely the battery because we saw that the voltage output dropped, meaning there's still input voltage. So this was not the issue. The transformer is an issue, and I should stop using this XL6000 because it can't even. I should use something which works with lower input voltage. Okay, this should work. Okay, this works. Let's close this, because this kind of, no, let's not close it, but this kind of works, so we don't need this anymore. So this is, input voltage 0. That's not possible. No, that's output. Input. Come on, it's not 0. Is the cable broken? Did I break the cable again and now we cannot measure the input voltage? It's not 0 because you're on. No. Yes, the input voltage is broken, and we have some dirt here. I don't want to open everything. Okay, let's not open it. We have some voltage. So let's try it again. No, you can't. Let's try to measure how much current it is capable of delivering. For that, I have here my electric load. This is my electric load. So this can be gone. Up. You don't have enough power to power this, but you might have enough power for 12 volts for other things. Let's close this first. This we know works. I'm ashamed that this switch doesn't work because maybe the cable when I soldered this cable, I think I desoldered the other one on the other side. I don't want to open it again. The input voltage is not too much important of a feature. So let's close this. Yeah, it holds together without the screw. It holds well together without the screw. It won't come off. And let's mark what this is. Battery. Protected. No charge. Up. And now let's have a setup for testing how much current it can provide. This is now testing more this thing than anything else, and the cable, but the cable is really short and thick. Shouldn't be too much of an issue. I need the receiver. We've had one somewhere here. It's starting to get really messy now. That's not the right receiver, and it's not on the cable. Where did I put it? I don't want to get another one. I know there's one here. If I can't find it, it's because it's too messy and I need to clean up a bit. So let's clean up a bit. Up until I find it. Here, this goes heatsink. This here, I found it. Didn't take too long. Here's my thing. Now let's connect the electric load to it. Plus minus up, switch on the load, and the minus is not connected. Now the minus is connected. Switch on the load, and you'll probably see the voltage. 5 amps, no. We start with something very low. 200 milliamp, that's the minimum. So let's try if it can at least deliver 200 milliamp. Here we should see we see the output? No, not as long as we run, but we will see it here. That's 200 milliamp. 12 volt output, that's fine. Now let's increase. What was this? Amp hour? I don't know what this error is. Ah. Huh? Okay. 8 volts minimum. Let's put it to 4 volts minimum. Maybe there was a small dip. So let's switch it on. 12 volt at 200 milliamp. Let's now increase. Nope. It's not able to deliver 300 milliamps. Let's try again. No, it's not even able to deliver 300 milliamps. So this is not a 1 amp. Maybe it is a 3 amp, but not for 3 volt output. Yeah, maybe it's just the output is the input is just far too low. Yeah. So 200 milliamp, not more, for 12 volts. It was still a fun project. I wish 500 milliamps, that would be nice, but error number 3. Okay, 200 milliamps works, and as soon as I make 300, you should see the dip. Maybe if I go slowly. $220, 230, 40, 60, 70. Okay, 280. It cannot deliver more than 280 milliamps when connected to this battery. But this battery is also not completely charged, so it might be able to deliver 300 milliamps, maybe. But yeah, for now 280. Let's put this to charge. Is this... Oh, how does this charge? USB. Let's charge it with USB. Let's charge it and let's see if it charges. Yes, it does charge. You don't see it, but I have a charger right on my right side. And it says that the battery is full. 4 volts is not a lot though. Yep, it says the battery is full. Yeah, 4.1 volts. That's we measure always almost the output of the battery. Well, c'est la vie. It doesn't work. Now the last one. This one. On this battery. Well, since it thinks it is full, I don't need to charge it. I will put 1S. How much was it? 6,000 milliamps? I don't remember. But this is also, you don't trust it. But at least let me battery 1S. So you know it's 4 volts output and not something more. So this is done. Next one. Up. Let's clean it. Let's clean the desk before we do the next one. There's far too much junk on this, so let's clean it. Up. This goes here. What good is everything has a place, so it's fast for me to put everything back. And I do this every day. First thing I do in the morning is clean up my desk. And it takes around half an hour to 1 hour. Up. Cable, are you long enough for me to get rid of this? Yes, this is done. Hot glue is done. This pen goes here. This file This goes with the file. This is with my, you don't see it, you don't see the half of my bench. You only see my bench, but I do have a side with power tools, and this is where the file was. This is my cable for the microphone because the wireless system is used. Shrink tube goes here. Solder flex goes here. That's the laptop. Cutter goes in the box. Cutter goes in this drawer. Let's do in this drawer. White pen goes here. Let's put a bit of alcohol on these hot glue things so it doesn't stick anymore. That's my component tester that goes here. This is the LC meter that goes here. Power supply goes here. Spade connectors, they go here. Switch goes here. No, spade goes next to it. I think it goes here. I don't remember where spade goes. Maybe it goes here. Cables, they go here. There's all kind of spudgers. They come in this drawer. These cables, I don't know if we need it anymore. Please put everything back in the bag. This scissor goes here. Okay. Okay, these parts go here. Mini spudger here. Metal file here. Toothbrush with the cleaning tools. AVG 30 with the cables here. AVG 20 here. One power resistor goes here. There should be a second one somewhere, and I can get rid of the box. Second power resistor. Crocodile clip. Then I can put the power resistor box where it belongs. Up here. DC switches. They belong here. Used tissue belongs in the trash. Epoxy in my glue drawer. Small screwdriver. Epoxy witness. Trash. Power meter. For now we don't need it anymore. So I need a screwdriver back. There's something on the ground. This cable. I have to. This is a remaining. I will put with. I do have a one-time cable with connector. This is a new part. Might get useful in the end. Power meter goes with my measuring devices. Solder goes here. That's we will probably use. Spudger goes here. Small spudger goes here. Crimping tool in this box. Second pair of scissors here. Shrink tube in the drawer with the soldering tools. Pliers in the box with the pliers. Caliper in the box with the measuring tools. This goes also in the box with the measuring tools. Don't ask me why. It used to be there. Pliers, tweezers with the tweezers. Magnifier with the microscope. This goes back into handy tools. Screwdriver goes here. Torch goes here. Now we have these connectors. They belong here. This is a done project, although it is broken because I cannot measure the internal voltage. I don't care. The input voltage. I don't want to open it again. too long time spent on it, and I don't think I will measure the input voltage very often. Output is more important. These are the battery tools. Belongs here. Pliers with the pliers. Connectors with the power connectors. I will probably still need it because I will have some battery, so I don't put it completely away. What is this? Huge crimping with the crimping. This is a banana plug. A banana plug. DC barrel jack plugs. Up. Almost done. Pliers. This is a 1S measuring. So where are my DC meters? Heat sinks can go here. Switches belong here. This is power device. This belongs here. DC meters are down on the bottom. I'm impressed by the small DC meter we just used, and I think I'll buy a new another one for panel mount. It's really good. I don't remember how much I paid for it. Okay, and these are just cables. This goes to these cables. I even have a bag full of these XH connectors. Belongs here. This one just fell out of it. This is a tiny screwdriver. I started using it for adjusting the trim pots, but it didn't work. This is the charger for the next one. And this is trash. See, it didn't take too long. I'm almost done. The desk is almost clean, almost. Do I have some crocodiles remaining here? One, at least two. Crocodile 1, crocodile 2. Now up this done, and multimeter leads. You come to the multimeter part. These are all leads from the measurements. So let's continue with the next one and the final one. This one, and this also works, and it works completely, but I'll never use it. It's an Acer. I don't know what it is. It's not written on there. There's a USB output. The particularity with this one is that the input to charge, that's not to charge. This is USB host. The charging port is this one, and you provide 12 volts. This is why I have this thing, which converts to 12 volts. i.onik tab, that's the name, and it draws 1.5 amp. So this is quite huge charging, and at 12 volts. Imagine which normally the 5 volt take 2 amps or something like that. This takes 1.5 amp at 12 volts. This is huge. So let's try to open this, and this one I have no idea to open because you see the seam go up all the way here. I think we have to open this side. But I don't know which side first. Probably this side, because here there are buttons. So it's probably the side which gets clipped afterwards. So let's try to open with... Are there some screws anywhere? Oh, we even have a drawer. What is this drawer for? For SD card. And there's a reset button. Here. Here there's an SD card, micro SD card slot, and a reset button. I'm wondering how this works. It's hard to put that on the camera. You still have the overview camera. You should see what's happening. Okay. Let's use, I have multiple of these patches and I think I need more than one. Up. Up. This one is for the prying. It's more the prying bar than a spudger. Ah, yes, it works. It's a bit easier than expected. Thought it would be a bit harder, but it's okay. Maybe the sides are harder. Okay, the sides I have no idea. Other sides glued on. They don't seem to have a tab. Do I need to remove this plastic piece and then there are screws hidden behind this plastic piece? Let's try. Yes. There are screws behind this plastic piece. Up. I think it's the same on the other side. I would expect so. Up, boing. You see that it's getting, the day is getting at the end. I'm getting impatient and I'm not concentrating anymore on what I'm doing. Else it would have fallen down. Since this is not professional work and this is not work I'm being paid for, I don't mind. It's a tablet which is that any... Oh, I'm not the first one to have looked at it. The screws are kind of used. I'm sure they were not this way from beginning on. Or else there's really crappy screws. I need to charge the screwdriver. But it is really useful. They're probably... expensive one. This is, I think I've paid under $10 for this one. Just look on it, AliExpress, and you'll find it. And it uses a 18650 cell. 1, 2, 3, and 4 screws. I don't want a box just for these 4 screws, but I'll put them where I don't lose them. And now we can try again to open the device, and now it should pop off by itself, and it kind of does, and I broke a piece of plastic. But I have no idea how else you would do this. Maybe it's lifting first on this side. Okay. Now I could have prevented. Here I broke this piece of plastic where the USB port is. We can add... Yeah, it's okay. Oh, It's a huge battery. Oh, that's good. 7.4 volts. So we have more output. This is yet another thing. And here you see, this is the input, 12 volts, which goes, which one is it? This, it seems here, this is the input. And who is the voltage? Who is the power manager? Everything is shielded. You think it is a bit more cramped inside, meaning that it is a bit more professional than the last one. Here we have a 2S, so we cannot use my auto. I could use something else. Yeah, so this will be a bit harder. Here is the battery connection. We have 2 times minus, 2 times plus, and then plenty of thicks in between. There are 3 cables, green, white, and yellow. I think that one is temperature, the other is the cell in the middle. You see plus minus, the cell in the middle. So you can balance it, which is mandatory for charging. And then I don't know what the last one is for communication. Like, there were also 2 cables for the others. I don't know what it is. Maybe there are 2 for charging. We could tap directly on the output. I would preferably tap on the output of the voltage manager if I can have access to it. I think to have access to it, I need to look under this shield, because this is the inputs. Here, this is RF shielding. Very probably RF shielding, because here is an antenna, GPS antenna. This is the GPS antenna. So here's at least the GPS module, probably also Wi-Fi. Yes, also Wi-Fi, because this is the Wi-Fi antenna and also probably Bluetooth antenna. It goes here. This connector is for the camera. This is USB. This is the main board. Here we have a connector to the speaker. This connector goes to, is it written somewhere? JP, no. I think it's the touch screen or the screen, all the screen. And they even marked the cables. You see, all the cables are marked. All the aluminiums are marked. So, I don't know, Acer? Okay. Acer makes good work. At least on this thing. We see plenty of markings. Shielding for... This is for heat. Where is it? It shields this, but we have a can already. It shields even more. I'm sure they had to put it, else they wouldn't add it, because this putting some shield here costs more money. Even also shield here. This is for the antenna. This is for the antenna. This is the speaker. Again, shield here. This is here. Apparently these connectors, the LCD connectors, are radiating enough, so they have to put a shield. Wait, it's not. Yeah, this is this. Up to here. And then you have plenty of marking, which is good for Intel. For us, 2012. Well, it is old. So yeah, this model is from 2012. It's not supported anymore. It still works though. So the battery is 9 years old. 9 years old. I'm impressed. It's well constructed. Well, good job, Acer. I can't say if it's done well for the others, but even here, these speakers are, how is it called? Are padded. See, speakers padded here, padded for good quality. You see some cables. All the cables are marked. Very good quality. I'm impressed. And now this shield, let's try to open this shield. This can is not soldered. Let's use a plastic prying tool and not metal. But I think it is clamped on. So let's remove the warranty sticker. Done. It's not under warranty anymore. After 9 years, it's not. Let's try to pop this can open. Well, it is not soldered. I see some lugs on the side, but it is still not easy to open. Let's try with a corner, the smallest corner. Let's try with metal on this side. Want to get under it. Ah, okay. This corner is done. Once the first corner is done, it's easier to open the other one. And having a nut shielded is also costing a lot of money because you have to solder all the clips. They even, that's fun. You see the marking. Maybe just this way. They mark the clips. They have a reference designator for the clips, which connects to nothing, but which still needs to be placed. And because there's a reference designator, it means that they have it in also in the schematic, because it's rare to have new parts in the board layout which you don't have in the schematic. So even in the schematic, they've added the clips. This is the input. This is very probably the audio. LVD something. This is probably the audio. This is the RAM. This, what is this? This is I know this logo, Wolfram something, Wolfram Alpha, no, not Wolfram Alpha, but Wolfram something, this logo. Yep, you don't see what I'm pointing at. This logo. I don't know what this is. This is normally power amplifier, maybe for the output, audio output here. I don't know. This is doing some power management, but not the one we're interested in. This is the main CPU, NVIDIA. Okay. Oh, this is a nice jumper. I don't know what it is used for. This is Alpha Omega. I know this logo. Oh wait, which was the logo? X Power. This is the logo I still need to find. APX, exactly. APX was the logo. Still I need to find with the X Power. This TI part, I don't know what this is. I would think this is audio part because how large it is. But it might also be video. I don't know. This is the one we are looking for. This is the PMIC, power management IC. And if we want to tap somewhere here. This is the input voltage. And let's have a look. TPS 659, TPS 659 something. Let's have a look. APX, exactly. I still want to find the logo for the APX and add it to my collection. APX power, was it this logo? Well, not rock chip, that's for sure. Chip down, no, chip down, there was no logo, it was really APX. xpowers.com. Let me switch to full screen. Xpower, that's the logo, the weird logo we were looking at. This is the logo I want to add to my collections of logos. Is it this one? I would have to look at the video again or at the device, but the device is closed. I will have a look at the video afterwards. But for now we're using, and I forgot the name already. TPS, that's the texture instrument part. TPS 659 TI TPS 659. There are plenty of them. 6591. I think it's 65911, but it's probably the same category. 6591104. So let's be more precise. 11. Yes, it exists. TI parts. There is a data sheet. Let's have a look at the data sheet. Power management unit top specification. So 2 step down converters again, but here we are 7.1 volt input, and then I'm sure there are plenty of protection. Thermal shutdown and hot die protection. Oh, that's all. Is there no battery protection, like minimum voltage or things like that? Isn't that the that's not the charger. It's not meant for the batteries. That's not the battery IC. That's the one for the processor. Oh no. Is dedicated application powered by one? Oh, that's weird. This is for one LiPo. We have a 2 LiPo battery. We have a 2S battery, 7.1 volts. So this is not the thing taking care of charging. The charging is done by someone else. There are plenty of other ICs. It needs to be buck converter, step down buck converter. So it means that it is either this one or this one or this one. Let's find out where the 7.1 volts, 7.8 volts go. 7.4 volts. Let's go to continuity tester. Continuity, this is plus. And now we just have to find the capacitors where the other pluses are. No. Yep. No. 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 This is the input voltage. Nope. Let me zoom out a tiny bit. This is the input. So somewhere around here should be the regulator. But it's not it. This is not this one. And it needs to be near a thick trace. This is the 7 volt output, correct? Let's measure. Between this and this, we have nothing. No, just wrong contact. 8 volts. That's right. Up. So here, this is the plus. So we need to find a capacitor where this. Oh, here. This is the plus. Is it direct? 0.18 amp. So it might be already from the output, and we see it goes here through this resistor, and then it puts here. This is 0.2 ohm. No, 0.2 ohm. Probably to measure the voltage. So it. Okay. So this plane is plus. So is this one the charger? This looks like a TI part also. Doesn't have to be. That's not the charger. So this is for stepping down, stepping up. This is for one cell only. So if we got the right number. Meaning this will not be the charger IC. This will just be the output. We want to have a look at the charger IC. It's maybe this one. Let me get again my magnifier. 10 times. Lights. And then let's have a look. This is BQ24171. 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 Yeah, TI. It wasn't written TI on it, but the way they do the marking is somehow, yeah. Battery charger. I was right. Standalone 1 to 3 cells. We have 2 cells. 4 amp synchronous buck converter, buck because we have 12 volt input, And this is the right data sheet. This is the charger. This is what we're looking for. We want its output. Typical application circuit. It is a bit small. 12-volt adapter. You see? It's a copy-paste probably of the application circuit. 12-volt adapter for the charging. Here is the battery input. Up. Here is the battery inputs, and somewhere should be the battery outputs. Because this needs to be able to protect the battery completely. Oh, here, system. So this is a PMOS. This is, what's battery drive? What's weird is that the body diode always gives power to system. Let's check the pinout. There must be more details. 40 pages, that's okay. PVCC, what is PVCC? Protection, blah, 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 blah. PVCC. Charger input voltage. Okay, that's not what we want. Something with battery outputs. What's bat drive and negative? Battery discharge MOSFET gate output driver. I think this is the output. Ah, no, I get it. Let's have a look back at the application circuit. You see, this is not for here we have the 12 volts. We know that PVCC, that's for the 12 volts. This is to switch on the AC or not. Here we have the 12 volt coming in, and then we charge the battery with the 12 volts. And this regulates how fast the battery gets charged or not. VBATs. Okay, so this is not the thing we're looking for. Where do we have the outputs? Oh, 10M. I think that's 10 milliohms. This is to measure how much current goes inside. Voltage ref, TS, thermal pads, battery driver. I don't see on the circuit right now. I'm probably blind. Where the battery voltage is used. It should be 2 pins. You see that P ground, that's normal power ground, that's for the input voltage. PVCC, these are 2 voltages. Although it's maybe it only is there for charging, but it's not there for protecting it. Let's check if it does over under voltage protection. Maybe it is just to charge. So it's not the right one. Protection. Adjustable over voltage. Okay. If it cannot protect from under voltage, this is not the part we are looking for. Protection. Input over voltage, reverse discharge. Okay, that's not what we want. There is no... Ah, here. Input over voltage on the voltage. Okay, this is for the input. Ah, but the input is the battery the input? System damage due to high input voltage. Do they mean that the input voltage is the battery voltage? No, I think they will say battery voltage. Input voltage is for the charging. reverse battery charge, over currents, undercurrents, that's, we don't care, charge undercurrent, battery short protection. Okay, but this, okay, the charger will shut down, but it doesn't mean that it protects the battery from charging, but not from discharging. Then the soft back to the charging current and pre-charge. This prevents high current may build up in the inductor and causes saturation. Okay, battery over voltage protection. Okay, now we are coming to, that's the end. No. Why can I not go down? How does this work? Continuous. Yeah, continuous. There is no protection for the MOSFETs, is there? An under voltage protection? There should be somewhere. Ah, here we have the typical application circuit again. I don't think there is. I think someone, at least this one is just for charging. It is not to protect for under voltage. Is there another one taking care of that? Let's try for under voltage. This is for the inputs. Inputs again. Okay, this is not the one taking care of protecting the battery. So we don't want its output, because I want the protected output. We need to look for another chip. Maybe this one. This, does it go here? No. Does it go here? No. So it's not this one. Although it could be more complicated how the battery, oh, it does. What is this chip? This might be the voltage protection, the under voltage protection. Here there's a connection directly from here to here. 604L battery. Try to find something with 604L. 604L liposots. It's at 20C6, something like this. Let's sort sots. Battery protection. Yeah, with the top marking it's super hard to find. Battery management. Yes. Thank you. It's probably the same as this one. The DV01. Let's try to find the pinout. DV01F or A? I don't remember. That's a battery protection. Let's see if the pinout matches. But it doesn't. It needs a MOSFET next to it. Do we have a MOSFET next to it? No, we don't. So it's not exactly the same thing. And let me look. This has only one pin connected, and two other pins, 2 and 1. Maybe it includes the MOSFET inside, but that would be weird. 604L. Yeah, I don't know what this does. Oh, LVDS. This is the screen. I was wrong when I told this is the screen. This might be only the touch screen. This is the LVDS connector to the LCD screen. This is pin 1, so pin 4, pin 5 and pin 6 are connected to the battery. No. Why doesn't it work again? Pin 5, pin 4. Pin 4 is connected to the battery. 5 and 6 seems to be for measuring. I don't know what this is. Pin 4 connected to the battery. Here, pin 4, test pin. That's not the same. That's not the same chip. Top marking. Power management. Yes. Sorts. Yeah. Let's remove this. This is too much. It needs this. I don't know. We could also just... We could. But we don't... the problem is... This is nice because it has a really high 12 volt input and it takes care of charging. So it would be really nice to keep this board because it takes care of charging it. Now we really want the outputs. I would say it's this thing, but I'm not sure. What's the voltage output here? If we see a voltage output here, no, nothing. Here, this is the 8 volts. So this is not the MOSFET charging, protecting it. Is there a protection inside? Maybe this battery comes fully protected. So we can directly tap on it. That's possible. Oh, it might. Here are the 2 cells, but here is some electronics. Maybe it does. But 1012 Acer. Okay. Yeah. Let's try to find something. But 1012. Does it have a protection? But 1012. Okay. It is... You can buy new batteries. But 1012. Okay. Can I have a data sheet? Ultra bug libraries. Yeah, probably nothing provides a data sheet. Acer. Do I have to open the device to find out? Products. Yes, this is probably the one I have. I want to know if it includes battery protection. Battery without opening it. Yes, I think we will not find out. Not easily. Let's open the device. I don't think we will find some information about it. Battery protection. We don't know. 4 cells. Okay, they're 2 times 2. That's possible. We might have to open this to find out if there is some electronics here. Can we just peel off? No, we can't. I have to cut. So let's use the cutter. Let's use the small cutter. And I have to cut some parts to be able to have a look on that scat. Yeah, I do have. I would love it to have. So let's be pretty cautious not to get more than we need. Ah, no, the battery charger. So there's a minus. The charging is not done by this thing, but it might include protection. Okay. Let's try to not short anything and not, most importantly, not puncture anything. Okay. There is electronics. You can see some electronics. So there might be some embedded protection. This board, is it just to connect the batteries or does it have protection? I think it has protection built in. Let's have a look. Let's disconnect the battery. Up, battery disconnected. And okay, let's bend it. Yes, this has all the protection we need. You see all the things here? It has more than enough protection. I'm sure that this takes care of balancing, fusing, and whatnot. Yeah, plenty of test points. I mean, it could be something else, but there are so many test points, and I see at least 2 transistor packages. There's one IC here. There's one fuse here. There are plenty of small components. I would be really surprised if you put so many ICs for not doing protection. So there might be protection in here, and the 2 cables might be data cables to speak with it. So cables protection is in there. So what we can do is just tap directly out of plus minus out of these things and port it and make it available to the outside. That we can directly. I'm confident that this has all the discharge protection and all the charge protection we want. And we can use this tablet and this charger to take care of this charging. Now, where do we want it? We will have cables coming ideally up, or ideally we could have them on this side. Let's remember, this side is the last side which you open, so we have to put it somewhere on this side. Up. Let me switch back. So let me switch back to the view bench view. You probably didn't see all the details, but yes, this has all the protection we want. So where do we want to put our connector? The connector must be on this side because the side this is the side which you have to open at the end. Here is the reset button. So we can tap here and put the cables along here, down there, and then output it next to the reset button. So here on this connector next to the reset button we could have an output, but this is a small thing. Can we put one of our Super XT? I don't have a lot of them anymore. This is the last one I have, else I have these ones, but this is far too large. And we can use smaller, but this would be nice if we could fit it inside. This plastic is well engineered. I don't know who oh, here even metal inserts. So this is yeah, Acer does good jobs. Having metal inserts in plastic is really expensive. Well, it's a lot more money, and the plastic looks very well engineered. So kudos to Acer for this one, for this product. It's a good job. How do I want it? I don't. What I could have instead of such a huge thing is having a barrel jack, like here. Something like this. It would be. Actually, we could, since we open, we can also have the connection somewhere here, since we don't have to plug. If there's space, does it still switch on? Well, we unplugged the power. Can we still switch it on? Where is the on button on this thing? I think, where is the on button? This is the on button. It's on this side here. Yes, I've heard the vibration and we see it is switching on. So this works. Let's switch it off. And this is where the on button is. Let's switch it off. Still booting, and this tablet works. So you could use two, and it has dual output. You could use it for audio. That would be fine. But don't connect this thing to the internet. This is super outdated. It will be owned within minutes. And nobody supports it anymore. So yeah, instead of having, so this is normally the charging port, we could have also this connector out this side. Here again, metal insert, and you see the plastic. Here they put some strengthening tabs a bit everywhere. Yeah, that's good work. It doesn't, so the issue is it's not allowed to go too much on the outside, too much on the inside. Here it would kind of, what is here? This is the screen. Oh, the screen is quite large. Do I have something else than these connectors? These connectors would be nice, but I don't think I would have the space. Although here I have the space, but then I cannot open the thing anymore. Although if I break here on the front, then I don't mind. There will be some, but next to the screw it is still stable enough. Yeah, if I make a hole here next to the screws, it would still be strong enough. Here is really not a bad idea. I think I'll put it here just next to the screw. But the screw then won't hold the plastic very well anymore. else I don't see lots of possibilities because these spades are large. On the bottom it's not or it is still possible, but this is beveled. It's on this either side. Here there's plenty of electronics and it won't fit. So we will put it here. I will put it probably I can shorten these leads. I will shorten these leads so I can put it right there. Yeah, I'll put it right there. Between these two plastic, I will shorten these leads. Then I can solder the cables on it, and then we will have the output. So let's do that. Let's shorten this using a file. I hope this is copper or brass and it is easy to file. No, it's not. Oh, it's still doable. It's not very easy, but it still works. Oh, you see, it is a bit shorter. Is it short enough to fit right here? No. Still needs to be short. Not too much though. No, it's okay. Is it? No, it's not. Still needs a bit more. Soldering on it will not be fun. I want to have it here. Not next to the battery, but no, next to the screw, but I still need to shorten it even more. We see I have almost nothing to solder on it anymore, but I will try to cut this leads so I can have access to the plugs a bit more. Which side do I want? Plus, minus? It's not really important. Let's have it on this side, and we see that it is an X connector. Now I have enough space. You see, I've cut the plastic and now I have enough space to solder on it. Yeah, it still needs to be a tiny bit shrunk down. Yes, now it fits. Now I need to cut the plastic in here. so the connector can fit inside. Oh, this is hard plastic. Damn it, I don't know what they're using. Oh, this is super hard plastic. Is it written somewhere? There should be a marking on the plastic, but it's probably ABS. I don't know. It is hard. I don't want to damage the structure too much, but I need to cut this. Oh, it makes crackling noises. Does it have glass fiber in it? No, it doesn't. Fiberglass, I mean. This you only put in plastic, which somehow needs to be very resistant, and it costs lots. Not just the plastic costs a lot, but the tooling for it, because the glass fiber you put in the just kills your mold quickly. So you just put it for high power tools or things like that. Okay. Up. Luckily, prying it is not too hard. Up. Okay, we have clean space to put this connector in this way. I need to cut this tab a bit. Can I cut it with this? I'm sure I will rather break. No. Oh, worked. Tiny bit more. Close the eyes when you do that, because this plastic flies everywhere. Oh, and it fits. Maybe it's a bit too high, but we can kind of, yes, it kind of fits. We could use the file here to lower it. Let me remove it from the table so I don't move the table too much. Okay. Filing is also slow, because I can't move a lot. Better. I think that's good enough. This is good enough. Will I be able to put the cables all along? That's a good question. It seems rather flat. I will put it here. I don't know how far I can put it. Yeah, I can put it down here. Is there some plastic here? Yeah, but I probably can, yeah, could put along here. Then down here I probably have to break this plastic tab and then all along here. So let's break this tab. This way. And this way I can go all along. Looks nice. Let's take the cable. Let's put the soldering iron on. Up. Oh, like always, this crash lands. Oh, and let's put this to charge meanwhile. Charge, charge, charge. Okay, this is charging. Let's prepare the cable. Oh, we need the wire cutter. A wire cutter, wire stripper. Up. third hand. Solder. Okay. Tweezers so I don't burn my hands while soldering. And we will put solder first on the board, so we have plenty enough solder. Well, I could put the can back in. Now it will be in the way. Let's solder first. These are the 2 pins. The 2 on the left are minus in black. Yeah, it was a good idea to put the solder on first. Okay. Oh, this is too long. Up. It's too close to the shield. Would be easier if I would use the appropriate tools. Okay, now this is close enough. This is good. Go down, then down here. Let's first do it also with plus. Is this tint correctly? Okay, now it's better. Plus, yeah, we will use red for plus. Let's tin it. A lot of people shouting outside. Is there again a football match today? No idea. This is the output. Did I do something? No, I didn't short anything. Okay, this is plus. Damn it. Use the tools. This is plus. Up. Does it have enough space to wiggle around? Let's try to measure if there's still output or if the protection kicked in because I shorted something. We are in voltage, yes. This should be minus 8 volts, yes, so this works. Let's pull the shield back on. So we've seen plenty of different ways how to do exactly what I wanted. Take the battery out, just add your, find out the chip which takes care of protecting and charging, if there is one. Have batteries which have it included. Add yourself one in, which we didn't do, but I presented it. That's good enough. So So now let's put the cables all along. Let's have it longer than we need. We can still cut it afterwards. And try to come on, don't you fit down here? Ah, I don't have to fit them down here. I can fit it above here. So this goes all along. Let me get some tape. Up. Up. Let me prepare some strips. Scissors. 1, 2, 3 and 4 should be enough. I should have a ruler actually for this tape. It would be useful. One. Then so this is power here. I will have a sec. Let's try to do as if we would care and put it somehow straight. Okay, this one doesn't hold anymore. Two. Okay, not that straight. Huh. Who said being straight is mandatory, huh? I'll put one more here. Details to attention. This one is straight now. I hope there are no structures on the... Oh, there are structures on the back. Let's see if we will be able to close it. Oh, damn it. The speaker. It's not only that, there is this speaker. Damn it. Can I go down here, or is there also the speaker? Speaker goes everywhere. I don't want to break the speaker. Under this, let's try to have a look what is under here. You see this cavity here? This is probably important for having good sound. I don't want to break it. It would be a shame for the good sound. Can I shift it a tiny bit? So I can have at least the cables. Can the cables go down? Maybe. Can we go below this thing? No, it takes the whole space. Okay, I didn't calculate with this thing. Then it goes back here, and then here. There will be one which goes down, the one which is furthest, so this is minus, the one will be down, the other one will be on top, the other cable, but I need... No, it uses the complete space. What if I go here? No, there's no wiggle room. Well, let's try to see if it closes this way. Yeah, let's hope it closes this way. Ah, I know what we could do. We will remove a bit of this foam. So we can have the cable use the space of the foam. That's not a bad idea. So, how do we put it this way? So minus, I also need to cut, so I have access to minus. And then I cut this on the side. Okay. Cutter. So let's remove the complete guard on all sides. Is the stream still working? Yes. Okay. Let's put some solder on it. I don't know what metal this is, but the solder sticks very well to it. So this we need to cut somewhere here. There's still some space, a tiny bit of space for it to move. Okay, this will be the minus. The minus will go from down. Oh, this is warm. Okay. Minus is connected. Oh. Didn't I wait long enough for the solder to solidify? Maybe just because it's large amount of copper. Now it should be solid. Yeah, looks dull. Okay, minus is there. Now the plus. The plus needs to be cut around here. A tiny bit more. Now I don't want to create shorts, so we'll disconnect the battery. Yep, battery disconnected. Now we are safe. Let's thin this wire. We can zoom a tiny bit so you can see more. Up. Let's hold this and let's try to solder the cable on it. Oof. Let's just try. I'll probably need a helping hand to hold everything together. Up, one. 2, and the helping hand is too short. This way. Okay, this is some good solder. You didn't see anything. That's okay. Now if we put it here, have a bit of space for plus minus. That's okay. I will put some, yeah, I don't need, I will just put some hot glue. Let's try to remove a bit this dampening foam. Up. I hope it fits inside. Yeah, we'll just add no epoxy, just hot glue, because removing this epoxy, if I want to fix this, will be a mess. So let me get again the hot glue, which I put away half an hour ago. To have some space. Up, hot glue. Now let's connect the battery. Oh, let's test if there's a short. Beep beep, beep beep. Is there a short between plus and minus? No, there is no short. Now let's test if we can measure some voltage when we connect the battery. Minus 8 volts, which is good, because this is plus, this is plus, this is minus. Can we switch on the tablet? Yeah, the tablet should be fine. But can we switch it on? Let's try it, because we need to wait until the hot glue is warm. Yes, we can. Maybe we can. I don't see any output. Did I press it for too long? I don't see any output. Hello? Did I short 2 pins I shouldn't have shorted? No, there's still the 8 volt output. It doesn't switch on. It makes roux, but that's it. What has been disconnected or broken? Is there some... Here it doesn't show the display. Problem is it doesn't make any sound at the beginning, but the display, I didn't touch it at all. This is the input. This looks nice. I have no idea why it shouldn't work. Why do I have to debug it? Can it charge? That's the question. That's the most important question. Don't know. Did I short pins on here? No, this is fine. I can't test. I can't see. But did I short the yellow pin from the battery? Let's disconnect and let's test it. Up. Continuity. did I so pin 1 and 2 are shorted, that's normal. Pin 2 and 3, no, they are not shorted. They are not. This is fine. Maybe the last 3 pins, the last 2, so the last 2 pins, are they shorted? Yes, and the one after it? No. So the connector is fine, I didn't short anything by soldering on it. So what is happening? Maybe we can press the reset button. There was a reset button. Oh, this was the reset button. This was not the on button. No. Maybe this one the on button. Let's press the reset button for a long time. And now let's press the on button for a tiny bit. It doesn't switch on again. The display doesn't switch on. What if I charge it? Here's the charger. Let's have 12 volt output. Where is this thing? Maybe it just needs to be charged for triggering something. Voltage, something 10 volts. That's good enough. Up. So you don't have to work too much. Let's test if it shows that it is charging. It does charge. I see 1 amp power consumption, which you don't see anymore because the script is dead again. Oh, I have to. I think this script has never been this program which reads out from the meter has never been tested for running so long. And I see some here, there is a charging LED. This is the charging LED, so it means that it knows that it is charging. Why isn't it starting? I mean, I don't really care, because I'll not use it. Maybe it would be nice to play music. Because you have an SD card slot. Yeah, it would be nice for music. Do I want to connect a debug port to figure out why it doesn't boot? Must be a reason why it doesn't boot. What did I touch? Cable look all fine. Didn't break anything in this region. Connections look fine. I just disconnected the battery once. Maybe I have to press on the reset button while powering. Ah, the reset button also. There is some intelligence. The reset button makes this blink. Oh, it did. Now it doesn't anymore. Here. Reset button. Did the screen die? Why would the screen die? Now what if I press a reset and power? Nothing. It can charge, it knows the reset button has been pressed. So there is some intelligence. So the display is kind of... When did this display broke? This is not my tape. This is the connector to the display. I don't know if it's the display who is broken or something else. I did touch some parts inside here. Maybe I did break something. We'll try it. So let's open this. Let's disconnect the battery so we don't make any shorts. Let's reopen the device. We know. And it complains that it doesn't find a battery. So there is some intelligence here. It says, oh, I have no battery. I have no battery. Please, I have an error. Help me. You need to help me. You need to tell me why you are not booting up. I don't mind. I just use it as a charger. But debugging, I like debugging. So let's have a look for a couple of minutes. So everything looks neat. Let's disconnect and reconnect the video cable. The joints look nice. Disconnected, reconnected. Let's use an ESD safe brush to maybe remove any kind of dust I would have put on it. No dust. The power has been completely removed. Let's plug the power. Let's have a look at this. 2 pins. 2 pins. That looks nice. Up. Plugged in. Let's start. What is this? Switch 1? What is switch 1? There is a switch on top, right? There's a switch here. I don't know what it does. Wait, what is there something on the box? Oh, this is lock and unlock. Ah. I don't think this makes any difference. Well, let's try it. I think this is just the key lock, the screen lock. And here we have, so this is the screen lock, and here we have plus and minus volume. No, that's not it. The CPU doesn't heat up. I don't think so. I didn't touch the LCD. What did break? The charger IC works. We've seen it charge. It's charging. The power management IC works because it knows it pressed on reset and it did vibrate, so it is booting. So something is wrong with the display outputs. The cable looks nice. And there's even a solder point here. Speaker. See nothing wrong on the display output. I did see it start last time. Maybe because the battery is not, no, it is high enough. It is 7.4 volts nominal. We are at 8 volts, so the battery is full. That's not the issue. So it doesn't, and even if that would be the issue, if we plug the charger, it would switch on the Linux OS in battery charging mode, which it doesn't. Well, maybe it does, but I don't see anything. Okay, I broke a perfectly fine working adapter. Perfectly fine working tablet. I don't mind, really, because I won't use it. But I still would like to know how. How did I break you? What did I do to you? So you don't work anymore. That makes me curious. I don't know why. Oh, this battery. Oh, damn it. I left the battery on. Now I need to charge it. Okay, this was not a... Is it rechargeable? Alkaline. Alkaline is not rechargeable. Yeah, battery is dead. Yep, I forgot to switch off my torchlight, flashlight. Okay. So let's solder these 2 points and let's see if this makes a difference. Desolder these 2 points. I will have disconnected this. I wouldn't see why, but let's try. This way we have it at an initial state. Huge ground copper plane. Up. Oh. Desoldering. Up. This should be fine. If these two are connected, these are internal connectors also. Okay, let's connect the battery back. I don't think this would have mattered at all. Maybe this... I never tried to remove the battery and then switch it on. Maybe it's not supposed... It's not working once you move the button. No, I don't think this would be possible. It would be really stupid. But no, it doesn't. Still doesn't boot, so that wasn't the issue. Can I plug it over USB? Does it do something over USB? Let me get to my computer. Up. Is it recognized as something? So USB tac. No, it's not recognized as anything. Well, it doesn't enumerate. Maybe this is the host port. No. Even when I switch it on, it doesn't enumerate as anything. So either it never enumerates because this is not a host device port, or this thing is broken. But it can still start charge, so that's good enough. That's all I wanted. I can still play music with other devices. Would be interesting to know what happened, but we won't find out this time. I don't see anything which is kaput. Nope. Okay. So let's just use it as charger. Yep. And I'm sure all the people who worked on it don't work, are not even at Acer anymore. Or probably most of them. So let's solder the cable back in. And the job is done. It can still charge. All I wanted is for it to charge. Up. Okay, that's minus. And plus. Oh, you're not seeing anything. Sorry. I just did solder minus and plus. Let's put some tape again. Yeah, I removed all the tape because I wanted to debug it. Let's put some new tape. Tape. Here is the tape. Hop. Hop. Okay, this didn't work well. 1. And 1. Let's put the shield back on. Let's put first the bat. No, first the shield. First, put some tape to hold everything in place, like this. We didn't test if we can close it. This might be a surprise too. No, first the shield. We can also put some tape here once we put the shield, and this way. Shield is back on everywhere. Up. It would be nice to test if, as a tempering measure, you just, when you have shield, just connect the shield clips at different pins, and then check if they're all connected to the same pin. If not, you know that someone is tampering with your device, and then you can, well, do the anti-tamper measures you would like to. That's a nice trick, because you have the shield no matter what happens, and you need to place things. So let's put some hot glue. Yep. The hot glue is not warm enough. Oh, it's warm enough. It's not very warm. I have to press really hard on it. Okay. Hot glue. Let's turn it a bit. Let's turn the heat of the hot glue. I don't have anything to do this here. Okay, now it's a bit higher. Let's keep it warm. We never know when we need it. Let's try a last time to reset and power it. And the screen doesn't work. I don't know why. The screen doesn't work. The charging works. Does the charging work? The charging works. There is the LED. Does the output work? Do we have 8 volts out? We have 8 volt out. The output works. This is all I wanted. So I broke a device. I don't care. I would never have used it anyway. So let's put the switch this way. I need to cut the plastic here. Marker. Let's keep it cool. We need to cut here to here. This is hard plastic. I'll have to use. I'm getting impatient. So I'm using my side cutter. Okay. This is done. This is probably in the way. Plastic tab gone. Can we close it? What I mean? What's a bit a shame is that when it charges, it shows you the battery indication. The battery indication tells you how far it is in the charge. This won't be there anymore because, well, it doesn't boot. That's a bit of a shame. But, I mean, put it on the charge and then just wait until it is charged. Okay, doesn't fit perfectly. Hup. Oh, it fits. I wouldn't be. I can't. Oh, I'm distorting the plastic too much. Come on, open again. Please open for me. The problem is I can't connect the battery input. Oh yeah, there's too much plastic. I need to remove more plastic, else I won't be able to connect the battery input. Okay, this, the battery connector, I mean the battery input, the connector, the male part of the connector. So I need also to, I will not cut this, I will file it. This is filed. Up. Can it still, does it still output 5 volts if I switch it on? That was a really useful feature. Oh, it does. So it works. It's still a power bank, and it probably is still on. It's just, it is probably on. Let me try to switch it off. Maybe it is on and just the screen is broken. Try to switch it off. What if I press on reset? Why is the reset button? It's somewhere hidden here. I'll not use this spiky stuff, but I will use this spudger. Oh, reset is too fine. Okay. Does it always? Okay. It is on. If I keep going, pressing on off, does it go off? Okay. It can go off. If I press, it goes on. The screen is broken though. I don't know what happened. I don't know what I did wrong to break the screen, but the screen is broken. I still can use it as a power bank. And yeah, well, it's not bad because the screen was the thing which uses most energy. So now at least when it is on, for the power bank device, the screen is not on, meaning it doesn't use a lot of energy. Maybe the LCD is still on, but doesn't drive anything. So let's call our destructive measure a feature, not a bug. Do we agree on that? Can I still connect this connector to it? Yes, it works. I need to remove more of it. I just have to write that the LCD will not go on. And there's a bit of shame that there's no indication when it's on or not anymore, but you just press enough time on the button, then it will go off. Oh, I have plenty of plastic now on my trousers. I'm getting impatient. I want to finish the day. Up, up, up. Now it should close cleanly there. Yes, it does. I can completely close it. Up. This is completely closed on all sides. Can put back the screws and then the plastics. And then we are done. We will still try the outputs. One, I think I forgot nothing, right? The covers come afterwards, yes. Two. There should be, I can already put these covers on. And two. Oh, that's also a shame that it doesn't show that it is on. Here it would be nice that if this LED would be on when it is on actually, but it's not. Yeah, well, it's not. I have no idea what happened. I don't know what it works, but we know it is on because when we plug USB, it is on. So let's switch it off. Off. And we can still charge it. We have the battery ports. This is 1 2 amp. And oh, I didn't think about that. I did not think about that. This cover here, well, it's in the way of the battery connection. Let's put the 2 screws first. One. And because this is not powerful, but you need powerful, that's good. So in the end, it doesn't damage the tab or the screw. This is ideal. So now the issue is that here, this cover needs to be cut. And we will cut it. So this is one side. Up. And now the other side needs to be cut right there. Still hold in place. Yeah, it doesn't hold. No, it holds. And now we can also try this device, and see if it can draw more current. So let's connect it. We should have power. Yes, we have 12 volt outputs, and now we can try how much current we can draw. I hope we can draw more because we have 7 volt outputs, so this might be completely fine. So where is my 12 volt line? This is my 12 volt line. No, this is not my 12 volt, this is my charging line. This is my 12 volt line. 12 volts. Then we need this adapter again. which we need to screw on. Minus to minus plus to plus, but the minus is a bit too short. This way. Minus plus. Let's try with 200 milliamps. Now let's connect the outputs. Let me show you what it does. Also, this is unreadable. Without filters, and there is no filter, it's also unreadable. But let's start. 200 milliamp. Error. What is error? The ground is not connected correctly. And this thing, I don't know if it touches. I think the ground is not connected correctly. Oh, it was connected. Oh, but somewhere else. Where? How did you get stuck in there? Up. Up. Error 3. It's okay. So let's connect it again. Okay, we have a bit less than 12 volts, but that's okay. I think it's probably lost through the cable. We have 11.8 volts. But let's try 300. Works. 4, 5, 6, 7. Whoa. 8, 9. 1 amp is enough. I will stop after 1 amp. We have 1 amp. So this could actually power the receiver. So let's try it out. This is the receiver. Somewhere here is the thing. Yes, it works. 300 milliamps. So this device, because it's not 1 cell but 2 cells, it's good enough to drive that. So maybe the other battery I want to do, no, 2 cells. 1 cell is 2 cells has really a lot of power. So the last device, we've collected from the first device from the Samsung, we collected these 2 batteries. Do I want to make a 2 cell battery out of it so I have more oomph for this, or do I want to keep it this way and then just make a 1 cell large battery? I don't know yet. Or do I just want to keep the battery like this? At least what we could do, the minimum we could do is put some tape here. So this works. Off. And then 0. This tablet can power this thing. This is some good news. Very good news. Let's put some tape on there so we don't short it accidentally. Whoop. Okay, there is some tape. So now this is protected. I have to decide what I want to do with this. Do I want to make a power bank? I don't know. But we are done. We've seen plenty of ways how to convert a tablet to a power bank. Just we can still use the charging from it. We broke one screen, which is fine. because I'll never use this Android. It is still charging, and all I want it for is to charge. It won't display the charging status in real life, but this LED will be white when it is full, which is plenty fine. And with that, yes, we are done for this schedule, and it's far too long. But yeah, it was fun. Almost 8 hours of work. Woohoo! But it was fun. So enjoy the weekend and see you.